Okay, let's ambassadors for a prayer. Almighty Father and everlasting Father, we thank you for this day of coming unto us, O Lord. We thank you, Almighty Father, for this opportunity to study in the morning, Heavenly Father. Heavenly Father, as we are going to study, I pray, O Lord, you may be with us. May help us grasp everything, O Heavenly Father. My Heavenly Father, I pray that we may understand everything that you are going to teach us, and may we reward him, Heavenly Father. And in the end, Heavenly Father, we should all of us get an A+ in mathematics. I have prayed this, trusting and believing in your name. Amen.
Amen. Thank you so much, Alvan, for the word of prayer. Let me hope people are well. Thank you so much for keeping time. Allow me now to share my screen, and then we start our session. Okay. I'm very sure my screen is on. Okay. Now, today we are going to look at another section, and this section today is data and probability. Yesterday we looked at this section and we looked at one part, and today we are going to continue with the second part. Under data and probability, like we said, we have different sections that we want to look at. However, I told you that for these sections that I'm giving attention to, also when you are making your revision, make sure you give them more attention. So yesterday we looked at state theory, and I gave you some numbers to try out. And today our concentration is going to be on data collection, display, and presentation. Those are the area that today, that's the area that we are going to look at. Now, as we start our data collection and display, there are some key areas that we need to look at. And those key areas, we are going to look at the frequency table, or what you call the frequency distribution table. We are going to look at the graph. We are going to look at the measures of the central tendencies. So the measures of the central tendency, this is where we have our mean. This is where we have our mode, and this is where we have our median. These are the major ones that we are going to look at. And here I'm also going to be able to emphasize which formula do you need to know offhand and where you need to concentrate. Then lastly, we are going to look at how do we make a conclusion when it comes to these statistics numbers. So those are the key areas we are going to look at, and we shall be able to do at least 4 items before this session ends. Now, what is the first thing? Alvan has prayed for us that all of us want to get A's, but we need to look out for the way how we can maximize those A's. How can we maximize such that we don't make any errors in our calculations? So when it comes to statistics, these are the things I want us to pay attention to. Number one, we are going to look at the frequency distribution table. So when it comes to the frequency distribution table, make sure that you use what we call well-defined variables. By saying well-defined variables in your table, I know some of you are used to writing things like, let me say, writing things like F. But F, you must define what is F. So in your table, when you are making your table, I expect you to say frequency. Now, in case you are going to abbreviate it, then in bracket you say F. Some of you are used to writing X, but X is not known. Define it that X is my mid value. So you also go on and define it. Don't just draw your table and just have F, have X, when you have not defined them before. So here, after defining that I have my class here, and what does your class represent? That it represents the weight of people. So you have your weight, you have your frequency, you have the mid value. Then since you have already defined what is your frequency and what is your mid value, then it is very okay for you now to abbreviate and have your f of x. Do not write CF like that. If you write CF, then define what does CF. Do you say that CF represents my cumulative frequency? So do not just write random things in your table without you defining what they mean. But if you have a scale down whereby you have said F is my frequency, X is my mid value outside your table, that one is also very fine. But don't just use things without you defining what you are using. Number 2 is what we call the coherency. Coherence means the logic flow of your items, how your table is flowing. Take an example. When you look at my screen, in case this is my table, we expect that your first one, in case you are talking about weight, and they have given you data that is not arranged and you have to arrange it, we expect you that you'll have now your tally, have your frequency, have your mid value, and other things can come in. But I don't expect you, or we don't expect you to come here and tell us that you have started with frequency, and then after you went to the tally, and then after you went to this. Or we don't expect you to have maybe that maybe you started from class boundary, and then you have the class. So make sure that your work is flowing. That is what we call the coherence. Check out that everything you're doing, it is flowing. Number 3, you must only have relevant variables. Do not put things on your table that you are not going to use. Take an example. When you look at the question that you're handling, they have not asked, you are not going to use the class boundary anywhere. You are not going to use the cumulative frequency anywhere. So do not include what we call irrelevant variables. So the first thing you have to do, first read through your items, read through and check out what do I need for me to be able to do this particular number. So do not include things that are not relevant. Take an example. You go on and find maybe even d is equal to x minus a. Yet even you are not going to use it anywhere. So do not just include things for the sake of you attempting, but make sure you include things that you are going to use. Number 4, make sure you have a crossed rectangle. Some of you always, at times you are rushing because your time has caught you, because maybe you think it is a bit irrelevant for you just draw an open table like this. You say this is my F, this is my X, and even you don't cross it. So make sure you have a crossed rectangle very well, whereby all your variables or what you have really put in the table are being crossed in a very good way. Then be neat. Be neat. By being neat, it means that do not over cancel. Let me say you have written your class, maybe 30 to 34, and you notice you have made a mistake, then you start doing like this. No, instead of you doing like that, you would rather cross the whole table and then repeat or draw a new table. Do not have your work when it is a bit shabby. Have your work when it is very neat. Like I've said, avoid those short forms of yours, CF, CB, and the rest of that. In case you have used them, then define them that CF is cumulative frequency, CB is class boundary. Number 7, make sure you allocate sufficient time for each step without rushing. When it comes to this frequency distribution table or to the statistics, one of the things that is very crucial that you must be very attentive to is what we call the tallying. When you are tallying, make sure you do not make any errors, because the moment your tallies are wrong, every other detail is going to be wrong on your graph. So make sure that when you are tallying, go step by step. Go step by, don't rush and don't look at your friend's work. Some of you at times, in case maybe you're sitting near your neighbor and you notice that maybe your neighbor has made something, please, for you, stick to your work. In statistics, we don't have a bright student, we don't have a dull student. All of you are bright. So what you have done is okay. But at times, if you keep on looking and basing on what your friend is doing, you may fail the number. So stick to your answer. And also I want to warn you that in most cases, the first answer you attempt or the first answer you write, in most cases, it is right. In most cases, you'll find that 80% of it is right. And some of you, those who have noticed, at times that answer you cancel, it is always the right answer. So please make sure you look at it. And after even making your tallies, and getting your frequency, please go on and count how many are they and confirm that what you have obtained is correct. Number 8 is the classes. When it comes to classes, your classes must be uniform. When you are generating the class width, when you are generating those classes, I expect, let's take an example. Here you have 30 to 34 as your first class. And I know here my class interval is 5. We do not expect that when you come to the second one, I know it is going to be 35 to 39. So I don't expect you now to come here to the next one and then you change, you say this is 41, maybe to 48. Here, it means that you have changed your class for this particular one. So do not change your class. For you always, you must test yourself. And how do you test? Now, when you look at my class, let me write here. You are looking at 30 to 34. You are looking at 35 to 39. You are looking at 40 to 44. In order for you to test whether your classes are correct, what you need to check out that whenever you have these two adjacent values, 35 and 30, you subtract them. 35 minus 30, you get 5. Any two adjacent values going downwards, once you subtract them, you must be able to get the same answer. 40 minus 35 is 5. 45 minus 40 is also equal to 5. So the moment you subtract them, you must be able to get the same answers. The same thing happens on the right. 39 minus 34, you get 5. 44 minus 39, you also get 5. So the moment you subtract these ones going down, you must get. But if you find out that what you are obtaining is a bit different, then it means that there is an error that you have made, meaning that you have to go back and check out what you are what you have made, what has not yet come out. So please, you pay attention to that particular thing. Then avoid having very many and very few class limits. When it comes to the classes, we expect that the maximum shouldn't go beyond 10. Never have your table where you have more than 10 classes. That one is going to disturb you. It will take a lot of your time. The moment you generate class and you notice that you have 10 classes, it means there is something you are not doing right. 2, if you have very few classes, you have 2 classes, you have 3 classes, it means that also you have used a very bad class width. So the minimum, at least you must have 5. Then the maximum shouldn't go beyond 10. Maximum can be 10, and then the minimum can be 5. Do not have very many 13, 14, 10, let me say 20. Those are very many classes. And that one, it is an indicator that there is something that you need to look out. That one, either adjust your class width or what you have used as your class interval in order for you to be able to get that particular thing that you really want. But I'm going to show you how we can generate those classes very quickly. So that is about the frequency distribution table. The moment you do like that, you'll find yourself getting all the maximum scores on that table. Then when it comes to central tendencies, okay, before even I something on the frequency distribution, in case the units have been mentioned in your values, please indicate the units, that weight, and then put weight, and then you say in kilograms. In case they have been mentioned somewhere, but in case they have not been mentioned, then don't commit yourself, just stick to what you have. In case it is age and it has been, then that is very, very okay. Then we have what we call the central tendencies. Central tendencies are the measurements that we can make. And always these measurements give us almost the same answer. So whenever you make your calculations, you are obtaining the mean, you are obtaining the median, you are obtaining the mode. Always here, the answers you get must always be within the same range. And I want you always to reason. Make sure you reason very well. Take an example. This is my table. If this is my table where I have, this is 30 to 34, this is 35 to 39, this is 40 to 44, this is 45 to 49, and this is 50 to 54. And I'm noticing that the frequency for these particular ones, I have 2, I have 4, I have 6, I have 11, I have maybe 7. And I'm going to make my calculations. It doesn't matter whether you are calculating mean, median, and mode. You must reason out. You ask yourself, which one is appearing most? that the highest frequency is on 11, meaning that when you are making your calculations, are you not seeing this law I'm highlighting? It means that your answers you are going to obtain shouldn't be very far away from this range here, 45 to 49, or slightly below or slightly high. So you must reason. If you make your calculations for mean and you get your answer, the highest frequency that appears between 45 to 49. So if you have used a very big class, your answer can either be slightly below 45 or above 49. But I don't expect you, or we don't expect you to get an ugly answer like 30 and 34. An answer between 30 and 34. An answer between 35 and 39. Your answer should be within these ranges here. So you reason out. Take an example, you calculate, you get your answer as 11. But when you look at your weight, even 11, there is no any class having between 11 and something. So you reason out. So I'm repeating, your mean, mode, and median. The moment you make your calculations, your answer should be within that thing. The same thing, even when you go to the graph to make approximation, let the frequency guide you that the highest frequencies between appears 45 to 49, meaning that the answer I'm going to obtain should lie within that range of 40, between 44 and 50. It should be within that one. It should swim within that. Don't get an answer. If you obtain an answer very far away or diverting very far away from that, then check out. There is something you have not done right in your calculations, and you must now pay attention. You must check out what is it that I have not done well. Okay, that is when it comes to mode, median, and other formulas. But which formulas are very important? If you have not mastered, the way I've put them in order, those are the formulas I want you to master. One is mean. If you have mastered the formula for mean, that when I'm obtaining my mean value is always given by summation of f of x out of summation of f, you are very correct. That is very okay. In case the formula for median and mode, you have not mastered them at this point, then now what you need to master is the cumulative frequency curve. But the most important one, please make sure you have mastered the mean. Make sure that at least this formula for mean, you know it. Even if you don't know other formulas, but at least make sure you know for the mean. Other formulas can come in later on, because for them you can even use another estimation method. But at least make sure you know the formula for mean. Then, after making your calculations, where necessary, please make sure you include the units. Like I've said, in case here your weight was in kilograms, then also put kilograms. But also, yes, that one is very important. Now, when it goes to the graphs, now when it comes to the graphs, I want you to look out for the key areas. Now, I'm going to show you my sample graph. Now, these are my sample graphs. Now, the key points when it comes to the graphs, one, have a title. This one is very important. Have the title on the graph that you are drawing. Number two, clearly label your graphs that these are number of farmers. Be specific. You can include your cumulative frequency, that I'm plotting cumulative frequency. But what is cumulative frequency? What does it represent? That it represents the number of farmers. Here I understand we are plotting class boundary. But what do those classes represent? Are they representing weight? So do not just put class boundary. Put what do the class boundaries represent? That they represent weight, they represent age, and put it there. Number two, if you notice my axes are well demarcated. Every after 10 units, I'm putting a demarcation. You are noticing these ones. These are what we call the demarcations. Clearly demarcate. Don't be careless for you to just write 30, 40, 50 without putting these demarcations. Please place in the demarcations. Then when you are plotting, you can either use that star or you can use the dot and the circle. Use what is easy for you, but we recommend to use a star. I know some of your teachers might have told you to use a plus, but a star is always better. So clearly show them. Number three, have a starting point. Have this starting point. And if you notice my graph, if you notice very well, when I'm making a starting point, I have not done like this. Some of you do ugly things at your starting point, whereby you come here and you write 149.5 when even the line is going through. You write here 0. No, have indicate very well that my starting point along this axis is 149.5. Along this axis is 0. And then you go. Have a clear starting point. Now, when it comes to the cumulative frequency, have a smooth curve. Use your free hand. Draw that curve smoothly as much as you can. So let it be smooth. And don't over repeat it. Let me say you have drawn the first one like this. And you know it's not coming out. Then you start doing like this. No need. Make sure your curve is very smooth and very clear. Then show, in case they have asked you to estimate something, clearly show those lines that show your estimation. These lines here, you are not seeing these blue ones. Show them clearly that those are my estimation lines. Do not just approximate. Some of you are very wise. Let me say that I've told you 45. For you just come on your graph, you place your ruler, and then you read off. Without showing them, clearly show it. Clearly use your ruler, draw up to when it meets your graph, and then come down, and then you show it clearly. But always have the title, have your axis well labeled, have the demarcations, have your smooth curve, show clearly the different things you are estimating from your graph. Hope that is very clear. We are looking at how to maximize all the marks. So that is about the graphs. Still the same thing happens when it comes to let me go back a bit to the graphs. When it comes to the histogram, please have those things, the rectangles well drawn. Make sure that they are well drawn very clearly, that are well drawn. So make sure you draw them very, very well. And and also you need to know that when it comes to histogram, when you are estimating, you'll always come and estimate like this, the adjacent bar. But God forbid, if you meet, now this one is just, I'm just assuming, God forbid, you reach the paper, you have done your things very well, and you notice that the mode, because now for that one, for the mode, in case you find yourself that you have two highest bars appearing, let me say you have those, and they're at the same line like that, and have to estimate the mode. Here, for such a number, you'll have to read off two modes. In case you meet such, you have to read off the two modes. So this is what you call them bimodal. It means that the number of the appearances are twice. So you'll come, estimate this mode here, estimate this mode here, and come, you read off that value. Do the same here, come, estimate here, and now like for such a case, let me say this is the last bar. Here, when you are estimating for the last bar, your line will come and meet at this point here. So I will bring it and I do it like this. Hope that is okay. In case this is your last bar, then you come and you read off like that. In another case for that by mode, you may find, let me say, these are your two bars. Are you noticing? When they are joined together. Now, still for this case, when you are reading off your mode, you will come here. Since there are two highest bars, still here you are obtaining a by mode. So you are getting two modes. Still do the same. Come, look at the highest point in the corner. I'll come, I do like this. And then for this one here, I'll come, I do like this. So I read off that value. So that will be one mode. Then the second mode, I'm saying these are special cases. For the second one, now for this particular one, I'll come, this is the highest point, and this is the highest point. So I'll come, I do like that, I'll come here, I do like that. Now for this one, since it has an adjacent bar, for it, I'll do like that. So please pay attention to that. So that one, I will do it like that. Hope that is very clear. That is for those special cases whereby, yes, whereby you have done. Now, two, we do not shade a histogram. Never shade it because you have to approximate. So meaning that when you shade it, you cannot be in position for you to, you cannot be in position for you to do what? You cannot be in position to approximate because you have already shaded. Yes, a histogram is very different from a bar graph. Bar graph, you leave spaces. Histogram, you don't leave spaces. But also I want to encourage you that when you are drawing these graphs, you learn to start from the origin. In case this is your last class, 30 to 34, meaning that here your class boundary will be 29.5 to 34.5. In case this is your first class, now this is your lowest class. Start from that point, 29.5, 34.5, and continue. Avoid starting like having a hanging graph. Let me say you come and you start from here, 29.5, 34.5, and then you have your graph coming like this. Many of you forget to put this continuity. So that's why I encourage always start from the lowest class. Your lowest class is where you should start from. But when we are plotting, do not forget that now you plot this upper variable. Okay. Okay. Now for by mode, when you are making your conclusion, you conclude that the number that is appearing most is this and this. So you give the both modes for that particular one. Okay, but that is a special case. I'm assuming that maybe you on a bad day, maybe. Yes. So that one we have talked about the graph. I've emphasized the title, axes when they're well labeled, demarcation, label with the units where necessary, have a smooth curve, estimate your areas, estimation of the areas clearly. Now, some of you have challenges when it comes to estimation. Because there are times, take an example, I have these graphs, and you are making an estimation. Some of you at times find it very hard to estimate. And now, what do you need to know? Is that when you are estimating, take an example, I want to check out how many, maybe something like that. Make sure, one, find out what this small box contained. Now take an example. When I look down here, in order for me to find my scale, I just get the one value, the bigger value minus the smaller one. I just get two adjacent values, which is 199.5 minus 149.5. The answer I get, this is I think about 50. I get 50. The answer I get, I divide by, from here up to here, how many small boxes do I have? When you check through, you will notice that you have about 10 of them. So then you say, I will divide by 10. So I will say 50 divided by 10 and I get 5. If you don't want to go through this and you are estimating along this axis where you have your class boundary, always get your class interval, divide by how many boxes you have jumped between two consecutive classes. In case you have jumped, if there are 10 boxes, then divide your class interval by 10 to get what each of that small box contained. So in case you want to plot any value, let me say you want to estimate, they have told you to estimate something. Always check out, let me say it is 300. Now for 300, I'm going to first come here along this axis, check out where is 300 lying. That 300 is between 299.5 and 349. I will come and say it is in between here. Now, this value you want to plot is always your highest value. So you get that highest value, 300, minus the smaller value before it, which is 299.5. Then I divide by what I have obtained as my small box. So for this case, it is 5. I divide by 5. The answer I get, I'm going to be counting from this smaller value here, the 229.5. I count those number of boxes that there are 1, 2. Then after I will draw and it meets my curve. So please make sure you estimate very well. And when it comes to estimation here, we don't expect you to have more than 2 decimal places because you can't read more than 2 decimal places. You must be very careful with that. So that is briefly about estimation. Okay. Then when you are making your conclusion, the last thing, When you're making your conclusion, don't round off to 0 dp. Unless the question, take an example, in case it is weight. Weight can have, like when you make measurements, let me say you are measuring cabbages and the rest of that. Those ones can have points for measured things. All measured things can have those different points. But the most important one that we need to be very clear with, when it comes to age, there are some things where you need to reason and ask yourself, but can age be points? Take an example. You have made your calculations very well and you have obtained your age as maybe 34.56. Age can't be in points when we are giving it. So here, have your answers 34.56. Then after, make an approximation and say approximately 35 years. And check out the signs I'm using. First, write your number to 2 decimal places, then make your final conclusion approximately 35 years. In case the conclusion, maybe they have told you, based on your calculations, what is this and this? Then for that one, please go on and write in words. Where units are supposed to be there, put the units. In case it is weight, say 35 kilograms. So put the units. In case they are newtons, you put. Then make sure you back up your conclusion with figures. At times they may give you a figure, and some of you at times fail to conclude with the figures. Give the reason. When you are giving the reason, give that say, basing on the calculations, the number that appears most is this, because it is the one with the highest frequency of this. So make sure that when you are back up with a reason. Yes, do not just back up, yes, without a reason. Okay, then after, write a full statement. Whenever it involves conclusion, make sure you have a full statement. Write a full statement that makes sense. Don't just write anyhow, things that do not make sense. Make sure that you write a full statement. Avoid those short things that the main is this and you stop there. Make sure you go on and you write a full statement that makes meaning. Yes, Imran. Let me take Imran. You can unmute.
Excuse me, sir.
Yes.
Sir. I have a question about
Yes.
the graphs.
Mm.
Um, I'm requesting to help me know how these graphs work, like as in the histogram and the ogive, how they are used, because sometimes they ask questions and you don't know how you're going to use the
Oh,
histogram.
okay. Okay. Yes, I'm going to show you. I'm going to show you. Okay, our next slide. But when it comes to histogram, it's mainly for numbers that appear most. Okay, now in order for us, Imran, I'm going to show you in the next slide. So in order for us to maximize place on that number, once you do all this, expect yourself to get order max. Even now on your frequency distribution table, I think even let me tell you the last one, put a title. Put a title on your frequency distribution table, that a frequency distribution table showing the weight of children. Have that title up there on your frequency distribution table. Okay, I have talked about this when it comes to frequency distribution table. What I'm saying that here up, you'll put your title, a frequency distribution table showing the weight of this, a frequency distribution table showing this. And then after you proceed and you make your thing. But do not forget to define. I've talked about the graphs. I've talked about the histogram. I've said, I repeat, histograms. Now, let me also throw now more light here. Now, when it comes to a cumulative frequency curve, whenever you read a question and a question requires you to estimate, here for frequency distribution, the hint that you should always get, one, if you find statements such as they have given you percentages, any percentage you find in the question, the first thing that has to come into your mind that is an ogive. It is the only graph that we can use to estimate, one, the percentages. Percentages are percentiles. It is the only graph we can use to estimate those percentiles. So for you, what has to come to your mind? The moment you see a percentage sign somewhere, then what has to come to your mind? That I'll need an ogive. And the moment you notice that you need an ogive, then think quickly that I'm going to need a class boundary. I will need the cumulative frequency curve in my table. Number two, when you find questions that involves estimating, estimate that over this and this, estimate over this and this, those estimation questions are also requiring you to draw an ogive. Then when it comes to a histogram, when you see histograms are mainly used for displays of continuous data. When you find, I'm going to show you a question, when they ask you to show how the data was distributed, then you pay attention to it. I know we have other graphs. Take an example, scatter graphs, we have line graphs, we have pie charts. I have not emphasized them here. I want you to first master these two, cumulative frequency curve and a histogram. Others, you read about them, but I explained about them, I think, in the previous seminars we have had. But I want you now, if you have not mastered these ones, first give them attention. Most important, first give attention to how we draw cumulative frequency curve. Do not forget a cumulative frequency curve, or as we shall have cumulative frequency against class boundary. But I've told you I don't want you to write cumulative frequency. Give what does cumulative frequency represent. Are they people? Then put number of people. What does class boundary represent? It represents weight. Put the weight there. Okay. And the same thing will happen when it comes to that. Trevor, you can first ask.
Yes, good morning, sir.
Good morning.
Yeah, so like on the graph, as you said about the on the axis when like we put the cumulative frequency and the class boundaries. So am I supposed to put there like all of the two words together, or I can choose to put there one word like weight? Like I don't put the word class boundaries.
Now, I want us to be always on a safer side. First, put the word that makes sense, which is weight. Then you can put your class boundary in brackets. But as long as you have weight and you have put what it represents, those class boundary and what they represent something. Are we together? The most important one is weight, not class boundary. So you put the weight because class boundary, what does it represent? Which quantities, which variables does it represent? That it represents this. Okay. We can continue. Now, someone was asking, what is a percentile? Percentile means out of 100. That's what you call a percentile, out of 100. So those are what we call the percentages. When they tell you this percentage and this, so at times take an example, when they tell you to estimate that 80%, when 80% of the children have arrived. Now for that one, always you say 80 out of 100 times the total frequency. How many are they? So whenever you find these percentages, what has to come to your mind? Always, I must multiply with the frequency or with the total frequency. Quartile, a quartile means the way you hear the word quarter. And now when it comes to quartiles, we have three. We have what we call quartile means dividing something into 4 equal parts. This is the first part, second part, third part, and the fourth part. That's what we call a quartile, quarter. Now, the first quartile lies here, is what we call the lower quartile. And we only look at the lower quartile. Lower quartile covers one part of the 4 parts. Then the second quartile is here. This is what we call the second quartile here. So the second quartile is what has a specific name. We call it the median. So for it, it covers 2 out of the 4 parts. And when you reduce it, you'll get a half. Then the third quartile covers 3 out of the 4 of the parts. So for it is what we call the upper quartile. So those are the quartiles we have. So lower quartile, a quarter. If this is 100%, a quarter is the 25%. Then a half is the 50%. Then the 3/4 is the 75%. So when they give you those percentages, when they say lower quartile, your percentage should be 25 out of 100 times the frequency. When they tell you the third quarter, then it means you say 3 out of 4 times the total frequency. So you say 75 out of 100 times the. But when they tell you 50%, like when the question says, find out when 50% of the children had arrived at school, in simple terms there, and they can say using calculations. So that one, they're asking you to calculate the median. They're asking you to calculate the median. But alternatively, whenever they give you those percentages, you can also use the formula for median. And for when it comes to that formula for median, it is just a matter of you where you have summation of f out of 2 minus your cumulative frequency before out of frequency of the median class times the class interval. It is only this part that you change. In case they ask for 50%, here, instead of having summation of f out of 2, remember this summation of f out of 2, it comes from here, where you are seeing a half, because it is the second quartile. So 2 out of 4 gives you a half of summation of f. So you just put that percentage, but I think I'm going to come at that at a later. Okay. Yes. When it comes to decile, decile means out of 10. So when they say fifth decile, it means 5 out of 10 when it comes to a decile. Okay, I'm going to come at that for percentages, but I'm going to still to recommend when it comes to percentages, the best approach to use is using a graph. Yes, the best approach, because you may find it hard or you may fail to interpret. Yes, Ruth.
So you, excuse me. So you just answered that question. I was going to ask that, is it really necessary if you know the formulas for you to plot the graphs? So you've answered me. Thank you.
Okay, good. Okay, I can continue. Sorry for the speed, but I'm going to reduce. Now, when it comes to calculations, now, there are some specific questions they're going to ask, and they want you to use the calculation approach. Now, I want you to type in the chat. I want you to read through the 3 questions, number 1, 2, and 3, and put in the chat whether for what are you going to calculate. I want you to either say, I'm going for that one requires mean, that one requires mode, that one requires median. I want you to type in the chat that number 1 is this, number 2 is this, number 3 is this, to check out whether people have an idea already now. Type in the chat, say for number 1, I would have calculated this. Number 2, I would have calculated this. Number 3, I would have calculated this. Okay, I'm looking. Okay, looking in the chat, I'm saying number 1, mode. Number 1, mode. Number 1, mean. Okay, 2, mean. Okay, Tumusime, yes, you can answer those quartiles without a graph by substituting in that formula of median. Okay, looking in the chat, I'm not seeing, yeah, we are there. Okay, now when you find such a question, they will say, based on your calculations, determine which age group was most. Now, this word should give you a hint, was mostly presented. You know that mode is the number of appearance, something that appears most. So for such a case, for number 1, it will require you to calculate the mode. So here, you would have calculated the mode. Number 2, give a reason based on calculations using the data collected. Suggest the time the assembly should always start. Now, for number 2, it is an open question. Being an open question, it means that any of these 3 can work for you. Your mean can work, your mode can work, and the median can work. However, because of the time constraint, because remember you have time, you need to mind about your time. Our paper is not 2.5, it is 215 minutes. You ask yourself, which one is easy to calculate? I've already told that the answers you get when you calculate any of these ones is the same. So here, I would recommend that you use the simplest one, which is mean. Because here mode, you can easily make a mistake in the formula if you have not been practicing enough, or median. So here, I would recommend a mean, but any other you use can also be correct. But also you must give attention to the stem of the question, because you might find that there is something that you need to pay attention to. Then number 3, based on your calculation, determine the average weight of the farmer's produce. Here, the hint has been already given to you. They want the average. And the moment you see that they want the average, then the average is mean. So here they have specified the measure that they want. So for you, the moment you go on and use mode or median, you'll be marked wrong, because it's not a correct measure. So looking through the chart, Galax median cannot work. Median is not an average. Median is like the middle value. So for number 1 mode, okay, looking through the chart, we are very fine. Okay. And now once they say basing on your calculations, here don't use the graphical approach. Stick to the calculations. They want to test whether you know those particular formulas. Okay. Then making a decision on the statistical graph. You may need to ask yourself, which graph am I going to draw? Still, I want you to type in the chat. Put for me either a histogram or an ogive, cumulative curve. Put in the chat whether ogive or histogram. You say number 1, I will draw this. Number 2, I will draw this. Number 3, I can draw this. First read through. Put in the chat. Now looking through the chat, number 1, oh, sorry. The past, yes, okay, thank you, X. Okay, I'm waiting. Okay, I don't know whether I'm not the one. Okay, number 1, ogive. Number 1, ogive. That one shows that people have understood. Number 1 histogram. Number 1, ogive. Okay, good. Okay, I'm seeing the answers are coming. Thank you. Yes. Now, like I've told you, things that involve estimating the number of students. When you read through the chart, which is turned down, who scored above 80? Now, for such a case, we shall use we shall use the ogive, as you have mentioned. You cannot estimate such using a histogram. You can never be able to do it. So here, the moment you estimate the number of this and this, and they have given you even what they have given you what they want you to find out, that one is always an ogive. The moment they specify, the moment you see a figure being mentioned above this, below this percentage, don't even think very far. That is an ogive. That is a cumulative frequency curve. However, in case the figure has not been mentioned, then that's why you need to think twice that now this one can be a mode. When you look at the second part, they have given you the percentages. I told you, the moment you say percentage, don't look very far. That one is also an ogive. Then number 3, want to stock the medicine basing on the age group that visited the hospital oftentimes. Now this one should give you the hint that oftentimes, that one is mode, because it is mode that describes something that appears most. Now here, where what do I want you to pay attention? Now here I have noticed that many times candidates fail to conclude very well. Take an example. The teacher wishes to know the number of who scored above 80. Now, many of you, after estimating on your graph, let me use this graph to show you what I mean. Many of you, after checking out 80, now they have told you the number of students who scored above 80. I'm using this as, okay, let me create space here. Okay, let me create space here, and then I show you what exactly. Now, take an example. Some of you are going to come very well. These are the number of students here, this side, and this is where the marks are. You have drawn your curve very well like that. The number of students, the highest, there may be 50. And maybe you estimated very well your 80. And you came here, you read off very well. Okay, you read off very well and you came and you read. And after reading here, you notice that the number here is 48. But the question was, the number of students who scored above 80, meaning 80 is this part up. Now here in your conclusion, some of you just go and stop at 48. You read off directly. 48 are the students who scored below 80. This part here represents those who scored below. If they say above 80, meaning now you are going to say that the class has the total number of 50. So you say 50 minus 48, which is equal to 2. And then you say 2 students scored below 80. Please pay attention. The same thing happens if you look at another question. You say students who scored at least 80. Still you do the same. At least 80 means greater than or equal to 80. So how many are they? Then you also do the subtraction. Or when they say the students that scored below 80. Now, in case it is below 80, your answer is 48. That one is very, very okay. You read it directly because all these ones are below 80. In case it is above, then get your total number of students, subtract from the estimation you are obtaining. Kindly let me know in the chat whether that point is clear when they give you above and when they give you below. Is that point clear? Just put in the chat that yes, we can continue. Is it? Okay, I beg your pardon. Not yet. Okay, not yet. I repeat. Now, I'm going to repeat this again. Now, when you look at our question, I'm repeating again. When you look at our question, this question we have been dealing with, they're asking us that the teacher wishes to know the number of students who scored above 80. Assuming that you have finished, you have done your work very well, you have drawn your curve smoothly, and here this is 50. And maybe I'm going to just estimate that maybe here you have estimated your 80, that my 80 is somewhere here. And these are the marks, and these are the students. So what do you do? I'm going to come to where 80 is. I demarcate very well. I come here and I read off here. Now, when I read off here, I don't want you to read points. In case you find that you are getting maybe 47.5, approximate this to 48. Now, in case you read here and you get your answer, let me say you have got your answer 35. Now, 35 means it is from here up to here is what we call 35. Now, these are the students who scored below 80. Here, this part that I'm going to shade, it shows me students who scored below 80. People who had 70, who had 40, and the rest of that. So those children were 35. But if the question wants above 80, now this part that is remaining up from 35 to 50 is the part that gives you those students who scored above 80. So what do? After you obtaining your 35 as the exact number at 80, then you are going to come and say the total frequency always, now which is the number of students, it is 50. So I will say 50 minus the exact number I've obtained, which is 35. Then I subtract those two, 50 minus 35, and I end up with 15. So I will conclude that those are 15 students. Because those are the ones above, 35 scored below. In case it is below, students who scored below 80, then I will just put my answer exactly the way I've read it, that it is 35. If you find the words that they can use above. They can use the word more than. They can use the word maybe a minimum, that students who scored a minimum of 80. All these words mean the same. Greater than. So in case you find these words, at least you need to pay attention. Say a student who scored at least 80, greater than 80, above 80, more than 80, a minimum of 80. All those ones, make sure you get your total number minus that exact number you have read. Okay. Okay, now they are telling me it is vo, it is more. Now, Lauren, yes, you can't write your answer like people. We don't approximate people in our halves. So for such a case, you round off like what Ruth has said. You round off to a whole number. So that is about it. Please pay attention to that. Many of you have noticed in these mock exams you have done, many of you stopped there. You didn't go on further to yes, students who scored below 80, you just say 35 students. Don't just write an open statement, 35. No, who are they? Those are students. So you say 35 students. Those who scored 80, those who scored 80 net, still you say 35. In case it is in writings, you can say they are less than 35 students. Hope that is okay. Okay. In case you are going to write your final answer, you say that the number of students who scored less than or below 80 is less than 35 students. Don't be specific because you don't know them. Okay. Now I can go on. I can go on to another part. So please pay attention. You do the same when it comes to histogram. Histogram I've already showed you. Now, how to generate the starting class. I've noticed when it came to the mocks you have done, for all the papers I've interacted with, many of you have failed to generate the starting class. When you are generating the starting class, I know your teachers have taught you a lot, but at times I want to just show you something you can do. When you are generating the starting class, I want you always look for the lowest value in your data set, that smallest number, or what you call the smallest number. After getting your lowest number, look out for the highest, the biggest number in your data set. For this particular data set, I've highlighted for you that the smallest is 15, the highest is 59. After obtaining those ones, then in order for you to know which class interval I'm going to use, now the best class interval are 5 and 10. These are the best. However, in case values are big, let me say they are in 100, 150, 200, then you increase. When you are going up, for you just multiply times 10. So this one can be 50, this one can be 100. In case they are in thousands, then you multiply again by 10. This one can be 500, this can be 1000. In case the digits are very small, dosible points, then you can also go down. You divide by 10, divide by 10. But the best I've said is 5 and 10. In case the values are very big, it can be 50 and 100, 500 and 1000. Avoid using those ugly class intervals of 3, of 2, of 4, of 7. They are correct. But I want to remind you that the people who are going to be marking you, they are used to 5 and 10. They are very used to 5 and 10. So for you, they will always look for the cheaper way. And remember, 5 and 10 are easy classes to read off. They are very easy. For someone can easily read it off. That's why I recommend those two, 5 and 10. But how do we go about it? Let me first. Yes, Ruth, a question?
Yes, my question is still about the starting bit, though I'm kind of taking you back to the ogive curve. I don't know whether it's the ogive curve or the histogram, but I think it's the ogive curve whereby there is a point we have to create create an extra boundary just before. Now, for example, if it's 29.5 to 34.5, but to get the starting point, maybe we have to create it becomes what? Does it become 19.5 to something like that? I don't know if it still applies in this case.
Okay, now what you do, Ruth, for those ones, there is no need for you to create those extra classes. You can ignore it. But in case it is what you are used to, it is also correct. It is very okay. But in case, let me say you have drawn your table, and this is how your table has been. Let me say these are the classes. This is from 1 to 10. This is 11 to 20. This is 21 to 30. Here, our class boundary is going to be 0.5 to 10.5. It's going to be 10.5 to 20.5, 20.5 to 30.5. Now, for such a case, when I'm drawing my graphs, there is no need for me to create an extra class, a class below the 1 and 10. There is no need. For you, what you need to do, have your starting point as this value here, 0.5. Place it here, the way you saw that I'm placing it here. Let it be your starting point. Then follow other values. Exactly. So you move like this. So you start from this first one, the lower one, go to the upper class boundary, 10.5, 20.5, 30.5, like that. And here you don't need to look for scale when it comes to class boundary because the class width at your level is the same. It is only when you reach HS where the class interval can change. But here your class interval will always be the same. I don't know whether that is okay, Ruth. Is that fine?
Yes, please. Thank you so much.
Okay. Elijah?
Yes, good morning, sir.
Yes, good morning.
For me, my question was about the object curve. Now you said when they say above 80, you look for number. The example you gave was 48. 40 students. Now, what if the question is 80, exactly 80?
Now, in case it is exactly 80, then that exact value I've got is what you put. When they say it is below, in your conclusion, you say the number of students who scored below 80 is less than 35. If they ask for exactly 80, you say it is 35. But in case it was below 80, then in your conclusion, say the number of students who scored below 80 was less than 35 students.
Okay, sir.
Okay. Lona?
Good morning, teacher.
Yes.
Good morning, teacher.
Morning.
Teacher, my question is about the ogive curve. We were told that the starting point shouldn't touch the zero. Instead, you make zigzag-like lines.
Oh. Yes, okay. Yes, now that is okay. But that's what I've been saying, Rona, that I don't recommend you using a zigzag. Zigzag is very fine, when you don't start from a zero, because zigzag means continuity. That much as I've started from this, but there are other classes that are coming below it. So this zigzag means continuity. Now, but what I want you is to avoid the zigzag. So to avoid the zigzag, in case this is your last class, the first class is 1 to 10. For you start from here where your graph is meeting here. Start from that lower one, which is 0.5, go to 10.5, like that. You will not have the zigzag.
Okay, thank you.
Yes, but also the zigzag is correct, in case you know how to apply it. But as long as you don't, forget it. Okay. Yes. Okay. I can continue. Now, I was still here. I have told you that the best classes are 5, 10. And in case the figures are very big, then you say 5 and the rest of that. Now, when it comes to obtaining your class, you first need to know how many classes am I going to be able to generate. Now, to find the number of classes you're going to generate, I'll get the highest value for this data is 59 minus 15 divided by. Now, if you find that your digits are between 1 to 100, for such values, use 5 to 10. When you find that it is between those 100s into 100 to what? I think 1,000. Here, that's why I use 50 and 100. When you find it is between 1,000 and 2,000, those big ones, there use 500 and 100 and 1,000 like that. So here I'm going to divide what? 1, I'm going to divide by 5. I ask myself, what am I going to obtain? So when I say 59 minus 15, divide by 5. Here my answer, I'm going to get 8.8. And now this one means that approximately I'm going to get 9 classes. That is the meaning. That when I use the class interval of 5, I'll come up with 9 classes. And I told that the maximum should be 10, minimum around 5. Then I asked myself, what if I had used my class interval as 10? So still I do 59 minus 15. It will give us 44 out of 10, which will give us 44 out of 10. Here is 4.4. So here it means approximately you use 5 classes. Now you take the decision, because when you look at 8.8, when you look at 9 classes and 5, all those ones are recommended. Then, however, the more the classes, the more accurate you are. You need to remember that the more the classes, the more accurate you are. Your answers become more correct. The same idea applies when you are looking at those things in physics, when you are looking at oscillations, that the more the number of oscillations, the more accurate you can be, because you minimize the errors. So the same thing happens when it comes to this point here, that the more the classes, the more accurate you are. So here, your accuracy will help you. Now, for such a case, I would recommend you use the 90 classes. But even someone who uses 5 is also very, very correct. So now, for such a case, but in case you get below 5, then for that one, automatically, you are going to go on and use the other one. Now, after doing that, I've known that I can use the class interval of 5. So you'll come, start from this very value, your lowest. Don't create other values below. No need to waste time. So I'll say it is 15, 2. Now to get this next value, if your class interval is 5, what you do? Remove 1. Remove just a 1. So you say 4. So here I'll say 15 plus a 4. I'll end up with 19. Then to generate other classes, keep on adding on your class interval of 5 of 5. So here I'll get 20. Here I'll end up with 19 plus what? 19 plus 5, which is 24. So here for you, just keep on adding 5. Continue adding 5, 5, 5 like that. This will be 25, 29, 30. This will be 34. And I want you to always check out these ones. These two values must be correlating. 19, 20, 24, 25, 29, 30. So that's how you generate those different classes. Look out for the smallest value, start exactly from that value, and go until you reach a point where your highest value has been covered. And here you are sure you'll have 9 classes. No, once you reach 9 classes, you stop. Your value will have been catered for. Yes, Ian.
Morning, sir.
Morning, sir.
You say that starting from 15. Now, what I was asking, what if I don't start from 15 and I start from like 10, then I use my interval 10 class width of 10 or
It is
5.
okay. It is okay.
Okay.
It is okay. But now why I'm saying that, some of you may go on and start with the class interval. Let me say, I know the class interval is what? Now, like for such a case, Ian, you have said you start from 10, not so?
Yes.
Now, when you start from 10, it is okay. You'll have from 10, and your class interval in case it is 10, you'll go up to 19, which is okay. But some of you at times, why I want you to always start from the lower, some of you at times fail to make the right decision. So you'll find someone saying, let me start from 4. So you say 4, and when you add your class interval, let me say you have decided to use 10, you'll end up with 13. So you're going to find yourself, you're creating an empty class somewhere that you're not going to use. So that's why I always avoid creating a figure that is not within the range. Is that fine?
Yes.
Yes. Number two, also you need also to reason. In case they are telling you, why even I am emphasizing this, in case they are telling you that the age groups that were sampled were between 15 and 59. And now for you, you're bringing an age group that is not within the sample space. Also, it brings about a debate in your calculations. Is that fine? In case they tell that the sample space, when they were measuring, they started measuring from the heights of people who are 15 and above. Now, for you, ask yourself, why are you bringing 10 that was not measured? So that's why I recommend that we start from the first one. But even when you start, but I don't want you to bring debates on your answer. That's what I'm saying. And whenever they bring debates on your answer, chances are high that you are going to be on a disadvantage. Okay. Then okay. Okay. Let me pick one more hand. Yes, Baraza. Baraza. Baraza, go on. Baraza, talk. Okay. I think we can go on.
Good morning, sir.
Yes, good morning.
Sir, morning.
Yes, morning. Morning.
Hello.
Yes, we are getting you.
I have one question. Could you so when like someone
Yes, Barak, I'm getting you, but unfortunately you are off, so I cannot hear you very well. So I'm writing something here that I want you, everyone in the chat, to tell me. You're going to tell me which you are going to tell me. You are going to generate for me the starting class. Everyone, you are generating for me the starting class. Okay. Yes. So I'm looking through the chat to see whether people have been able to generate starting class. Okay, people are saying 30 to 35, sir. 30 to 35, 30 to 34, 30 to 34, 30 to 33, 30 to 34. Okay, very good. Thank you, thank you, thank you. 30 to 34, perfect. Yes. Now, when you look at the values we have here, you are noticing that our lowest class is equal to 30. And your highest value is, when you check through, is it 54? Yes, I'm saying the highest is 54. So we have said that first find out how many classes you are going to generate. So I will say 54 minus the smallest, which is 30, divided by my lower class, which is going to be my class center when I use 5. So when you use 5, you are going to say 54 minus 30 divided by 5, and you'll end up with 4.8. So 4.8, the moment you get 4.8, this one is an indicator that they are going to be approximately 5. In case you get an exact number, always just know there's one more additional class you'll get. So this one means you'll have 5 classes. And we say that 5 classes is very good. But in case someone had used the 10, you will say 54 minus 30, which will be 24 out of 10. This one means 2.4, which is free classes. So this one is very, very bad. So here the best is using this. Then I've told you that after now identifying that the class you are going to use is 5, the class interval is 5, then you are going to come to your table here. Now we are generating. Now here, when you look here, our table here, they are using ages. So you are going to come here and say ages. Now, after putting your ages, the first that is going to appear is your lowest, which is 30. So I will say 32. Now, your class interval, always just subtract a 1. So it becomes 4. So this 4 is what you add on 30 to get the next, which is 34. Remember, when it comes to class interval, or to get a class interval, always you get 34 minus 30, and then after you add the 1. So this one we are subtracting is this one here. Yes. Or if you use your fingers, you can count 30, 31, 32, 33, 34. So the moment you subtract the 2, you must be getting a number that is 1 lower than your class interval. So then the next classes, we shall have 35 to 39. We shall have 40 to 44. We are going to have 45 to 49. Then we shall have 50 to 54. So you are noticing that all your classes are being covered. Now, for someone who used the class below 30, let me say for you, let me start from 20. Now, if for you started from 20, you are going to notice that you'll have your classes, but there will be even more. So that's why I always recommend we start from the lowest value. Okay, let me hope now that concept is okay. No one should fail. Now, we go to the next one. When you look at our data needs to be grouped. And when you read through the question, they ask us, hope the health coordinator organize the ages of the participants to aid the interpretation. So that one, they're requiring you to have the frequency distribution table. So like I've said, now here you are going to start with your heading. Now, what is your heading going to be? A frequency distribution table showing, or you can say showing, or you can say representing the participants representing the participants whose ages require healthy attention. Now, the next thing you will do here always, whenever you find that your data is not grouped, you are going to have the tally. Now, I want you to do your tally now in your book, as I also do. I want to recommend, whenever we are making these tallies, please cancel out to avoid you making mistakes. Say 30, cancel it out, you put the stick. 32, cancel, put the stick. 41, cancel, put put where 41 lies. 42, cancel, put. 46, cancel, you put. 53, cancel, put. 45, cancel, put. 43, cancel, put. 49, cancel, put. 52, cancel, put. Can I allow you complete yours as I complete mine also here? Complete yours in your book as I also complete mine, and we see whether we have the same answers. And when they reach 5, please don't forget to cross. Wait. I want you to, this is 46 members. It's not, this one is 46. Don't write 16, it was 46. Sorry about that. Okay. You are going to confirm whether you have also you have the same thing like what I have. Then, like I've told you here, you write your word frequency in brackets. You are going to put F. So here I have 2. I have here 4. I have 6. I have 11. And I have 7. So please confirm that also you have that. In the chat, just say yes, yes, yes. If we have all that, the way I have them there. Yes. So masculine, we have said the class interval of 10 will not be appropriate because you are going to get very... Yes, sorry about the 16. The 16 was supposed to be 46. The 16 was supposed to be 46. Brian, we can correct it. Okay, Frank.
Good morning, Joe.
Yes, morning.
Actually, Mr. Tally on 45 to 49.
45
to 49, Mr. Tally. We are doing.
They are 10. No, did you include this one? Was supposed to be, instead of 16, it was supposed to be 46. Did you change it? Yes. Frank, hope you are saying. I think it is correct, the table. Members, do we have the same table? Looking in the table, Frank, they are saying that it is okay. Kindly check out. Kindly check out. Okay. Now, yes, Frank?
Oh, I've seen, I'd seen it, I haven't seen it before.
Oh, okay. Now, after drawing, you read through your question. They want you to organize the ages of the participant to aid the interpretation. Then they're asking you, construct a representation of the data to show the age distribution of the participants who need urgent attention. Now, when you look at this question, I want you to use the chart. How are you going to represent them? What do you think we are going to use to represent? Which kind of thing do you think we need to? Let me look through the chart and I see where the members now. Cherry Denise, 40 to 44. Isn't it 4? No, check out. So looking through the chat, what do you think? How are you going to represent? Please put in the chat histogram. Histogram. Very good. Very good. Now, when we are drawing a histogram, we have said now we need the class boundary. So meaning that in our table here, we are going to include class boundary. And we know that when we are getting the class boundary, when it is a whole number, we subtract 0.5, we add 0.5. So please kindly check out that you have 29.5 to 34.5. So the lower one, you will say 30 minus 0.5. Upper one will be 34 minus 0.5. Okay, so let's generate and complete that table. 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5. Okay, now after finishing doing that, now we have finished the first phase. Here I know the total frequency, I think it's around 30. You just confirm. 8. Okay, I think yes, it is 30. Now, after doing so, we are going to go to our histogram to draw it. Now, let me take you to my graph such that they want us to construct the distribution and we show the edge distribution. So now, like I've told you, when we go to our histogram, I'm going to start the way it is. So I'm going to come, I want them. This is my graph I have. Now, when I come to my graph, I'm going to be very clear. Now, on my graph, let me reduce it a bit. I'm going to come, use a ruler. I don't have a ruler here. Now, when I come, I'm going to draw my line. That is my line. Use a ruler. Me, I don't have here. So that's why I'm using a freehand. Have your graph drawn. I'm also going to come here. I draw another line. And if you are not seeing that I trace the board lines very well. Now, when you look back at our table, our classes were 29.5 to 34 Okay, 29.5 to 34.5. Then we had 34.5 to 39 point, okay. Allow me to, what can I do? Okay. Let me first erase here a bit. So when you look back at our table, you are not seeing that we had our classes from 29.5 to 34.5, 34.5 to 39.5, 39.5 to 44.5, like that, 44.5 to 49.5, 49.5 to 54.5. And according to our frequencies, we had the 2, we had 4, we had 6, we had 11, and we had the 7. Now, when I'm here, when I go back here to the table, you can easily notice that our class boundary, it represents age. Now here on my graph, I'm going to put age. Then on the vertical, the frequency represents the number of participants, or it represents people. When you read the question, they will say the healthy last year following the ages by the participants who say those are the number of participants. So here I'm going to be very specific and I say number of participants. You write in words a number of participants. Then you check out. Now here when I'm starting, I'm going to put the demarcation and I start from the exact value that here my class boundary is starting from 29.5. Put 29.5. Jump your 2, 34.5. Jump the 2, 39.5. Jump the 2, 44.5. Jump the 2, 49.5. Jump the 2, 54.5. That is okay. Then go to the here to the vertical. When it comes to the vertical, we are remember for histogram always frequency against the class boundary. So when you look at our frequency, we are noticing that the highest figure is 11. So here there is no problem. For you can say, let me use 2, 4, 6 like that. So now I can use that one as my class. I say 0, this is 2, this is 4. I'm jumping to 2. This is 6, this is 8, this is 10, and this is 12. Now, after that, I know this is a histogram, so I must have my heading. Then I will say a histogram, my heading, a histogram showing the number of participants, showing the number of participants. Now here you can first read through number of who's the number of participants whose number of participants who need healthy attention, who need healthy attention with, you can use with or against their ages. Yes. Clearly define what is your graph showing. It is showing the number of participants, and what is the intention of the graph is to find out how the how is the distribution of the age vis-a-vis their healthy attention. Yes, Frank and Daniela, unmute.
I would like to ask, should that title be in capital letter?
No, no need.
Okay.
But you can do any that is easier for you. Yes, Frank?
Okay.
Yes, teacher. I was asking, in the title, teacher, is it essential for you to have like the last part where you also include how often you visit the center, or you can just
Yeah.
show, or you can
How
just
do,
say a histogram showing the number of participants.
now you can't stop there. You must be very specific. What is it showing, and how is it plotted, and what is the instance of the graph? So the graph is to show us the healthy conditions or healthy thing that the people need, and we are plotting the number of the people who participated with the age distribution. Okay, looking through the chart, just okay. Okay, now after that, we are going to plot. The first one is 29.5 and it has 2. I'll just come here. I draw my thing and the 2. Between 29.5 and 34.5, we have a frequency of 2. That is it. Now, for such a case, there is no need for you to have the other continuity. Those people who create external classes, or who don't start from the starting point here, you will always have that. Then the next one is 4. I'll draw like that, like that, like that. The next one is 6. I'll draw like that. You're noticing that even the scale I've used, all those things are there. 6. I go to the next one is 11. So this one is 10, 11, 12. I'll come here. I'll draw like that. I draw like this, I draw like this. The next one is 7. I'll come to where 7 is. 7 is here and here. Then that is how the graph is represented. Here, they can as well go on and ask you, which age group needs urgent attention? Now here, you reason out that the age group that needs urgent attention according to our graph, you are noticing it is between the 44 and the between this is what? It is between 45 and 49. So you will say, basing on the graph, the group that will need urgent attention is the group with the age within the age group of 45 to 49. Why? Because the number, according to the samples that were taken, this age group had the highest number of people who, yes, who needed medical attention, who needed assistance. So now this is how your graph should look like. Now we go back to the question. when we go back to the question, they asked us that construct a representation of the data to show the age distribution who need urgent attention. Now that one is okay. They just told us, they didn't tell us to estimate or the mode and the rest of that. Yes. Then I'm saying Trevor.
Yes, sir. You have talked about the on the like when like concluding on your graph, you said from 45 to is it to 40? Is it like to 40
45 to
something?
49.
Yes, to 49. And on 49, I'm seeing there 49.5. Why are we not using 50?
Now remember, these are class boundaries.
Yes.
And remember we said age we can't give points. Are you getting it? So
Yes.
44.5 is approximately 45. 49.5 is approximately
50. But now for you said 49.
I said, oh, okay. Now why I said 49, when you come back to the age group representing 44.5 to 49.5, when you come back here on your graph, which age, which class boundary corresponds to that age group?
It's done 45 to 49.
Yes, 45 to 49. That's why I said so.
Okay, thank you, sir.
Okay. Okay. Let me hope now that you are is very, very okay. Lastly, Shami and Elijah, unmute. Yes, Sammy.
Okay, sir. I would like to know that if the working space on the graph is essential.
Yes, it is always better to leave your graph when it is neat.
Okay, now like the working space, now like for yours, you have left a big space on the other side. So is it?
Yes,
So
that
can
is
you
okay. Now, one thing you are going to notice, now that
Yes.
one will always come in physics, it is not good. But for math, when it comes to math, a smaller graph will always be easy for you to read and it will always be very accurate.
Okay, sir.
When you draw a very big graph, in most times you'll not find it so easy to read.
Okay, sir.
But
Thank you.
there is no problem you drawing a bigger one, as long as your graph at least is covering a half. So for math, make sure it covers a half.
Yeah, I've got it.
Okay. Elijah?
Yes, sir. Thank you so much. I was kind of requesting to ask if you are allowed to use other statistical diagrams, for example, pie chart.
Now,
yeah.
Okay, now for a pie chart, mainly will come when the question involves things of sharing. That's when you can use the pie chart. When it involves things of distribution, things of sharing things, that's when we use the pie chart. Each of those statistical graphs has a major thing that it does. So don't just use it because it is a statistical means. No, read the question. The first thing is to read the question, understand, and then make a decision. I don't know whether I have answered you. So for this case, you cannot use. Yes?
Thank you.
Yes. Okay. Then Lona and Queen V. Yes, Lona? Lona, unmute.
Good morning, teacher.
Good morning.
Yeah, Chat, I wanted to know, when you're doing this, do you need to also put the scale, like the vertical scale and the horizontal scale?
Oh, okay. For math, there is no need. For math, there is no need to put the scale because there the scale is automatic. So scales are marked on the graph for you for using it. But for math, it's not so important.
Okay, thank you.
Okay. Then lastly, Queen V and Gloria S's. Okay, I think they're failing to unmute. We can Queen V and Gloria Esther. Gloria SS? Okay. Queen V? Okay, I think let Gloria SS. Okay. Okay. So, okay, we are going to start. Now, for this graph, please never shade. Never shade it. You leave it the way it is. Okay, we proceed to complete this question. Now, after that, you have done part B. Part C, based on your calculation, determine which age group was most represented. Now, here they are very specific. They want you to use the calculations. Now, look at this, the age group that was most represented. Still, this is an indicator. They want you to find they want you to go on and find your mode. Now, I always encourage that first highlight when you are finding the mode, highlight what law has the highest frequency. When you look at our frequency, this one has the highest frequency. So this is what I do. I first highlight this. That everything I'm going to do, I'm going to use that law because the highest frequency is 11. Now, after doing so, I'm going to go, allow me now to create a new slide here. To create a new slide here. Okay. Now, after doing so, I'm going to come on my new slide. I've highlighted it very well. Now, in that slide we have highlighted, we are going to write our mode formula. That here, they are looking for the mode. And when they are looking for the mode, I have to know the formula. I will say that mode will equal to the lower class. Now here, use what you have learned. Use what you have learned. Do not stick to what I'm giving you, but stick to what you have learned or what your teacher has told you. So I know it's going to be lower class plus D stands for deviation, D1 plus D2, then times the class interval. But I've told you always, it is a good practice to label. So say L1 stands for lower class boundary of the model class. D1 stands for model frequency minus the pre-model frequency. D2 stands for the model frequency minus the post-model frequency. Then say C stands for my class interval. After now doing so, it means that you have really defined what you really want. Now I go back. When you look at our table, what we highlighted, you can check back. The law that I highlighted had 45 to 49. In it, it had 11. And above it had 6, below it had 7. This was the frequency column. And then here it had 44.5 to 49.5. You had it like that. Now, what am I going to do? This law that I have highlighted, when you check back, is where I'm going to extract my values. Remember, okay, I think it went out. This is what we highlighted. I highlight it like that, this one here. Now, I'm going to come back here. Then I say L1 is this lower class here. So I'll say my lower class is 44.5 plus. D1 means the model frequency. Model frequency is that highest frequency that appears minus the pre means before, or pre-mock, the mocks you did before you did your final mocks. So I'll say mod, which is 11, minus the one before, which is 6, out of post is, so D1 still will be 11 minus 6 plus D2 is the model frequency minus the one after. Post means after. Then everything I'll multiply times the class interval. And for this particular one, we use the class interval of 5. So I'll go on and I say this is 44.5 plus 11 minus 6, that is 5 out of 5 plus plus 4, then everything times 5. So this will give us 44.5 plus 5 out of 9 times 5. So I'll continue and say this is 44.5 plus, this is going to be 2.77. Let me calculate. That is 5 divided by 9 times 5, which is 2.778. And when you add, you'll get an answer 47.278. But like we have said that here, when we are making the calculation, we cannot conclude like this as our age. So now I want you to check. I'm using approximately. There's a difference between equals and approximately. So here we are using approximately. So I will say approximately 47 years. So I go back to the question because based on your determine which age group was most represented. So the age group or the age, in fact, here the best word would have been the age that was most represented. Here, I think we can edit. Based on your calculation, determine which age was most represented, not the age group. It was the age that was most. So here, which age was most represented? So the age that was most represented were people or around 47 years of age. Now, after doing that calculation, you ask yourself, that is your mode, the number that will appear most. So it is between 47 to 49. That is the age group that was most represented. Now, in case it was the same question and maybe they had asked which age group was most represented, you can still go on and make the necessary adjustments. Then for part B, they're asking, provide recommendations to the health coordinator based on your data analysis. Now, on your data analysis, here we are looking at basing on what you have calculated, what you have seen, what would you recommend? So can someone raise up the hand and we give some recommendations? How would you recommend? Looking at our question, which recommendation are you going to write? You can put it in the chat because now we need to recommend. Yes, now here we don't use the graph. I've seen someone who used the graph to estimate the mode. Here we don't use the graph. Reason being that they have said based on your calculations, determine which age group was most represented, meaning they wanted us to use our calculation approach. Yes, I repeat, histograms we don't shade. The reason is because at times you are required to use what? You are required to estimate. Now imagine you are finished to shade and you have to estimate. How will you be able to see the values? Yes, so that is how you need to reason that if I have shaded, how will I be able to okay, I think the debate, so okay, I don't know whether I'm saying correctly. Okay, but I'm waiting. I recommend that people between 47 to 49 years need medical attention. That is very good. Thank you, Mulunji Ezra. People who are old were more sick in a number than the youth. So you must, yes. So your recommendation can be that I would recommend, and remember it is you who is recommending. So don't say we recommend. No, you say I would recommend that the healthy coordinator gives more attention to the people whose age group is between 47 to 49, because these people are more susceptible, or these people that age group, many people appeared to have healthy issues, so they need to be given more attention such that this and this such that maybe they do not do this and the other. So that's how you need to recommend. But each one of your recommendation, basing on the data, will always count. So that one you need to pay attention to it. Hope that was yes. So many of those people within 47 years, within that range, 47 to 49, they need a lot of with 47. Okay. Yes, so I'm saying that your recommendation. Yes, okay. Yes, you cannot that why I'm saying 47 to 49. Now it depends which recommendation would give, but it's not people of around 47 years. People around 47, 48, 49, they need that more attention. Yes. Yeah, and that age group, that's where people start forgetting. And in fact, even in human nature, when someone is about to clock 50 or when someone clocks 50, there are some things psychologically that come in. Those people will always be a bit quarrelsome. Something very small can piss the person off. So there is something that usually comes up with that age group. Yes, at Gonza.
Excuse me, teacher. What if you say that I would recommend that the medical center should give attention to people above 47, 45 years?
Above 45 years. But okay, according to our mode, we are not saying that our mode is 47.
Yes.
So you're saying that you'd recommend 47, is it 47, I think? Yes, you'd recommend 47 and above, to give more attention
Yes.
to people above 47 years.
7 and above.
Yes, 47 and above. That is also okay. Distant junior. Okay, I think, yes, we got 47 by calculating the mode when we calculated. So that's why we are saying 47 and above. Distant junior and Gabriela.
Yes, teacher. Good morning.
Good morning.
Our conclusion and the way we are setting it, I'm realizing that we're giving reasons like vulnerable and likely to quarrel. So are we just supposed to come up with a reason to give?
Oh, now the reason now for this case, no, I'm not that one. It was just I was just expressing, telling you what happens in real life, but you shouldn't come up with such. Here, your reason should be because when you make basing on the calculations, we have noticed that the number of people above 47 years appears most because the number that is appearing more. That's why you are recommending it. But don't give those health issues because you are not sure what are they suffering from. Is that okay? Hope that is okay. 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 Now we are going to continue. Allow me to, so that's how you attempt that number and you'll have your 20. So allow me, I know you are very tired, but allow me we do one more. I had prepared, I think, about 4 numbers that I wanted us to do, but allow me that I open another item. Each of these items, they had some specific things that I was looking out for. So you'll just excuse me that let's do, but do not worry. When you get exhausted and you drop off, we shall always have the link shared. We shall always share the everything we have discussed in your absence. Now, there are situations, this is our second item. There are situations where you are going to find that the table has already been drawn for you. Once you find such, thank God that everything is going to be easy for you. Why? Because at least now, the table is very easy. You can easily manipulate it and then go about it when it is already drawn for you. But so it means that, oh, someone is asking me to zoom in. Hope now it is a bit clear. Yes. Now, when the table has been drawn for you, it is an indicator that life is going to be very easy for you. Now, when you look here, they're telling us that a food company is planning to introduce chicken on their menu. And the employees researcher to investigate the opinion on the weight of the package that will cost 12,000. The researcher decides to conduct a survey on a random sample of people to gather their opinion and use the, now here, give attention to the stem. At times, some things are hidden within the stem. And for you may rush before you read it. So they're saying that the researcher decides to conduct a survey on a random sample of people to gather their opinion and use the average weight, meaning that according to this particular question, what we are required is like to find the average weight. That's what is going to be based on in order for us to determine which package should be costing 12,000. Should it be 5 grams? Should it be 10? And the rest of that. Now, meaning that when it comes here to your question here, that giving a reason based on computation using the collected data suggests a suitable weight of fried chicken to put on the menu. Meaning that here, if you had misreading the stem, you cannot be able to collect to get it correct on part A. Here, not all central tendencies will work. You calculating your median, calculating your mode will not work because here they are specific. They want the average weight, meaning here they want you to calculate the mean. And you know now, after finding out that they want me to calculate the mean, the next thing that is going to come to your mind is that what do I need when I'm calculating the mean for that particular one? Allow me, because I'm going to reduce. Hope my screen will remain a bit big your side. Is the screen visible? I want to utilize this space to draw now our table. We are starting the solution. We say that when we are starting the solution, we shall always have a table. So we shall say frequency distribution table showing the weight, showing the weight, showing the weight and the random sample of people, something like that. Okay, now afterwards, we draw our table. Now in our table, here where they use the weight, we shall use the weight. And please always extract that table back. Do not just fill in the examination room. So I'll have the weight. Then I say from 1 to 10, 11 to 20, 21 to 30, 31 to 40. Okay, I'm going to make the table bigger. 31 to 40. Then I have 41 to 50. Then here, they were specific. When you look at the question, they used number of people. So here, for you do not write your things there. So I will say number of people. Now, mathematically, you need to know that number of people is what represents the number of appearance, which is frequency. So for you now in brackets, you are going to put F. So this will be 8. We shall have 14. We shall have 12. We are going to have 9. We are going to have 7. Now you are going to allow me, for me, I'm going to put lines. For you, don't need to put lines in exams. Reason being that those lines are already there. But here, since I don't have them, allow me to put them there. I will put them like that, like that, like that. Now, I know I am finding the mean. Mean, we need the mid value. So I'll come here and I say mid value. Now, mid value, always we represent it by X. In case you're using midpoint, is okay. Now, to obtain our mid value, always we go to our weights, the classes. So I'll say 1 plus 10, everything divided by 2. Now, please and please, those people who love using the calculator, put a bracket. Some of you just go to the calculator, you put this. This one is totally wrong. A calculator is going to give you wrong answers. It will only divide it 10. So make sure you put a bracket. Those who are putting in the calculators. In case it is, so you say 1 plus 10 in brackets, then divide by 2. So hope that is okay. So those who have divided, please work out and you see what we get. So here I'm getting 5.5, 15.5. Type in the chat what you are getting for the rest. 5.5. Keep typing the next one. What is the next one according to your calculation? Zoom user, unmute. Yes. Keep getting the next ones. Keep getting those next ones.
Good morning, everyone. Good morning, sir.
Good morning.
So, at the beginning of the lesson, at around 5, you had mentioned that the table should the ogive should have the axes. So we did not put them in the previous example. So I was wondering if it's necessary or not.
Oh, which one? The axes that they are there.
They are labeled or not?
Oh, labeling. And there is no need for you to label. Labeling the axis, I was meaning putting the age and the number of participants.
And then my other question is, you said we form like a frame or a boundary around the table.
Yes. This
that's
frame.
That's necessary.
Yes. The way you are saying my table is closed is what I'm saying.
Okay, sir. Thank you.
Okay. Yes. Hope this is what everyone is getting. Okay, very good. Now, after getting this, since you have already defined your f and x, then it is very okay for you to have fx. So kindly multiply. Anyone with a calculator, you can raise up the hand and you tell us. Fx means multiply the number of people with the mid value. Anyone with a calculator, you can raise up the hand and you tell us.
Okay, 5.5 times 8 is 44.
Okay.
Then 15.5 times 14 is 217. Then 25.5 times 12 is 306. Then 9 times 35.5 is 319.5. And lastly, 7 times 45.5 is 318.5.
Okay.
Yes.
Okay, kindly go on and give us now our summation. Sammy, you can. Sammy and Tabis.
Okay, thank you, sir. Good morning.
Good morning.
Sir, I think because you talked about the abbreviating, I'm seeing again if I abbreviate the f of x.
Because yes, are you saying that I've already defined my f and x? Are you saying that? That's why I'm using the abbreviation, because you have already defined your f and x.
Okay, sir.
Okay. Just the cumulative frequency is 8 for the first one.
Okay.
8 plus 14 gives you 22.
Okay. The first one is 8.
8. Then 22. 22 plus 12 is 34. Plus 7 is 41. Sorry, it's no. There's 43. Is it? Yes, 43. 43 plus 7 is 50.
Okay, good. Then the last one, we shall have the class boundary. Please, you close your table. Now, allow me to, okay, let me, I'm saying, Sammy. Sammy. Yes, Shami.
Sir, good morning.
Good morning.
Sir, how do I know that cumulative frequency is necessary here?
Okay, now, when I go back to the second part, part B, you are noticing they told that the supervisor wishes to know the number of people who prefer a weight greater than 25 grams.
Yeah.
Yeah, and I told you when you meet things that involve estimation, what has to come to your mind that you are going to draw an ogive. And an ogive, you need the cumulative frequency and a class boundary.
Okay, thank you, sir.
Okay. Okay, now let us complete this table, but allow me to minimize mine. As for you, complete your table. Finish that column of class boundary, everyone. Let me first minimize and I write in small letters for my values here to fit. So here, I expect you to have 0.5 to 10.5. For you, subtract very well. I think my handwriting may not support me well to 20.5. So for you have it drawn very well. 20.5 to that one. 30.5 to 40. Hope people are understanding 40.5 to, because I cannot write it here clearly. So I expect you to write it on your ends. For you write it because I cannot write it very well here. Let me hope we are there. Now, after that, I'm going to go to the second. Let me hope everyone knows how we get the cumulative frequency. Cumulative frequency, always move your first class. Move your first class. Now, this is our first class. This is the 8. I'll move it here. After obtaining that 8, then you keep on adding. That here is 8 plus 14. You get 22. 22 plus 12, put 34. 34 plus 9 is 40, 43. So you keep moving it like that.
I think we need the summation F there.
Okay,
to answer
the summation of F. Very true. We need it. And what do you get? I'm adding quickly here. I'm saying, is it 50? Yes, and for the summation of F, I'm basing on this, on cumulative frequency. Always the last value on your cumulative frequency must align with your total frequency. Those two must always align. Okay, now I come to part A. Give a reason based on computation using the collected, suggest the suitable weight of fried chicken to be put on the menu. Now, to be put on the menu, they said they want the average weight. Now here I'm going to come and on my calculation and say part A, average weight. I want you to reason now, don't use mean because you are saying the question is asking for average weight. So you say average weight, which is this out of this will equal to 1205 out of 50. And this one will give me, when you will be 24.1. Now, check out in the question. Our weight was given in grams. Then I will put here 24.1 grams. Now, because they told us based on giving a reason. Now here in you must conclude, you must give a good conclusion that I would recommend or I would suggest. Now here, since it is a suggestive statement, you say, I would suggest that the average weight should be 24.1 or 24 grams for the fried chicken because the average weight basing on my calculations or basing on my computation is 24.1 gram, and therefore it should be the one that should be costing 12,000 Ugandan shillings. So you make a good conclusion and include in the figures. Hope that is very fine. Kindly let me know in the chat whether it is okay. Okay. Everything, all these numbers, please, for you keep on. You are going to see where we shall use the assumed mean. We have a number on it. Okay. Now, part B. Part B, they're asking, the supervisor wishes to know the number who prefer a weight greater than 25 grams. Now, like I told you earlier on, that for a weight greater than 25 grams, greater than, when you find that you are estimating, here the ogive should come into your mind. That's why we have included the cumulative frequency and the class bounded, because we need both of them. Now, what are we going to do? Let me get my graph. I hope I'll be able to get this graph. Okay. This is my, oh, okay. Let me get another color. Graph. Okay. Oh, which one did I want? There's a color I wanted. This one is not so. Okay, now this, oh, I've already used this one. Okay, let me use this, no problem. Hope the green can be seen clearly. Now, when it comes to this graph, still for our ogive, you are going to first have a heading. You'll say your heading, because I've told you, we don't need to leave any mark because now remember your class is the testing class. So please, for you, make sure you write everything as long as it is relevant. So you say a cumulative frequency curve, a cumulative frequency curve. Now, you go back and first understand the question, that what was the question requiring? You go back and you read it a bit. So our question, looking at the question we are attempting, our question was saying, this question wants us to show the number of people who prefer weight. And the question is about weight. So meaning that when you are designing your title, according to the data that was corrected, we are looking at it. So I'm going to say a graph, so a cumulative frequency curve showing the number of people, the number of people with the corresponding weights, So put the title, put what is the graph showing, what is it containing, that it is a curve that shows the number of people, and then their suggested weights. Now, after doing so, we have said that for these graphs, we are going to come and draw a good graph. So allow me to draw, but please for use a ruler. Don't fall, because me, I don't have a ruler. That's why I'm using a free hand. But use a good ruler and draw. So I will draw. This is my curve. Draw a good curve. Let me say, I don't know. I think you are going to allow me to minimize. Allow me to minimize this graph a bit, such that I can see clearly what I'm drawing. For you, draw a better one with your ruler. Assuming now I put the demarcation. Never forget to put the end point that my graph is ending. Now, yes, even if you say an ogive, it is okay. It is okay. Yes, but because we want to bring out that concept of a curve, but it is also very okay. Now, afterwards, you are going to label cumulative frequency. Now, you go back to your question. You ask yourself, what does the class boundary, what does it represent? When you look at the class boundary, you are obtaining it from weight, meaning that the class boundary is representing weight. So I'm going to come here and I put here that this is weight. And if they are units, put the units there that these are grams. And in case, I know there are very many various spellings. Some of you at times you want to use yours. Please stick the one that has been used in the question. Yes, Imran.
Excuse me, sir. My question is that when I'm drawing the graph, am I supposed to leave two, as in those two spaces that you have always been leaving?
Okay, it looks very neat and decongested.
But sometimes those values are always many and they cannot fit.
Yes, now even still for those things, you can jump out that car one, but it is okay, there is no penalty. But just because I want your work to look neat, but there is no penalty, leaving 1-1.
Thank you, sir.
Okay. Nash and Victoria.
Good morning, sir.
Good morning.
I'm asking that on our graph, how comes you don't have the y and x axis? Yet you said we have to include them on the graph.
Oh, now, labeling the axis, what I meant is you writing the weights, putting the labels that this is representing weight and my y-axis represents the number of people. Is that okay?
Yes, thank you.
Yes. Yes, the x and y axis, that one we shall use it mainly. You'll put it when it comes to coordinate geometry. When it comes to coordinate geometry, when it comes to linear programming, we shall include them. But here there is no need.
Okay.
Labeling, I mean putting those different things. Okay. Now, after, we are going to extract. When you look at our lower class is 0.5. So please, I will start from that lower class of mine. Like I've already emphasized and I've already asked you. Yes, so that's what we shall always start with. Now I'm going to come on my graph. So you draw your graph. In fact, we can draw, we can draw together, but also start. So I'm going to jump to, because like I want my work to look neat. This is 10.5. From 10.5, I have 20.5. From 20.5, I'll have, what do I have? I have, I think, 30.5. From 30.5, I have 40.5. From 40.5, I have 50.5. Now here, remember it is cumulative frequency. Come back to your cumulative frequency. Now, when you look at our cumulative frequency, you are noticing you have 8, 22, 34, 43, and 50. Now here, you can just read the scale using your head. Alternatively, you can use the concept of physics. You get the highest minus the lowest divided by the number of boxes. But I don't know whether you can. That one is very okay. You can use that one. So when you get the highest, it's going to be 50 minus 8 divided by around 10. In case you want to use the half of the graph. So this will be 42 out of 10, which is 4.2. And in convenient scales, you will note that 4.2 lies between 2 and 5. So you can use 5. It is very okay. In case that one is really going to disturb you, I can recommend that use for you the scale of 0 to 10. That one can also work, whereby you start from 0, you set 10, 20, 30, 40, 50. Though your graph will be very small, but also it is very okay. Yes, scale can be 5. Yes. So here, since people are using 5, I will say 5, as long as it fits 10. This is 15, 20. This is 25. This is 30, 35, 40, 45, and then 50 here. Now, when you are plotting, please take note. Now here, you are going to first check out from 0 to 5, because some of you don't know how to use those small scales. So in order for you to find what each box contains, you say, now the first range is from 0 to 5. So I will say 5 minus 0 divided by how many boxes are there? That there are 10. So I will say 5 out of 10, which will give me 0.5. Now, in case the value, like here, our first value we are going to plot is 8. What do you do? I'm going to come on my graph. I come back on my, so this is my graph. Each small box contains 0.5. Given you have started from 0, now you notice that 8 is between 10 and 5. So I will say 8 minus 5 divided by what the small box contains. So 8 minus 5, you'll find that you get 3. 8 minus 5 is 3. Divided by 0.5, you end up with a 3 out of 0.5, which is 6. Meaning that from 5, you count 6 boxes. But the first class, here 8, corresponds to the upper class boundary, which is 10.5. So here I'll come to my graph. I check where 10.5 is. 5 is here, I'll count 5, this is 6, 7. Let me zoom in a bit such that people can actually get to this point. I've zoomed in a bit. Now I come back here. This is 5. So I'll go to the next one. This is 6. This is 7. And this is 8. And I plot it with the upper first class upper, which is here. So I'll come here and I put a star like that. So now that is my point 8. So those who can, this scale of 0.5, it means that every after 2 boxes is 1. The next one is 20.5 and it is 20.5 and 20.5 goes with 14. Still, if you don't know, come ask yourself, where does the 14 lie? 14 lies between 15 and 10. So you say 14, the value you want to plot, which is 14, minus where it lies between 15 and 10, minus this smaller value below it, divide by what each box contains, which is 0.5. So then you say, and here if you are placing them on calculator, put a bracket. So you say 14 minus 10 divided by 0.5, the answer I get is equal to 8. Meaning that from 10, I'll count 8 boxes. So I'll move 20.05 is here. This is 10, I'll count 8. 1, 2, 3, 4, 5, 6, 7, 8. Then I'll come here, I put that star. Kindly, let's complete the rest as I complete my graph also here. The next one is 34. 34. So I know this is 30. Okay. Mine I'm going to reduce and I see clearly what I'm plotting. But let's complete. Yes. Hope you have got the idea. 30, 1, 2, this is 30. 1. You plot 43. Mm-hmm. 50. So you'll have a graph of that nature. Let me minimize it a bit for people who are not seeing. So that is roughly how my graph is looking like. I expect your graph to be like that as well. Yes, that is what we are getting. Now, after, you are going to use your hand, your free hand, to come up with the curve. Now, you come up with a good curve. Now, and when you are drawing your curve, once you start, go, don't stop to doing bits. So I can have something like this. Now, this is the mistake some of you do. Are you seeing my graph? Some of you stop at that point and you say you have finished. These graphs must be closed graphs. So the moment you start from here, your lowest class, please just come and start from the origin and continue up to the origin like that. So that is your graph. And there you'll obtain all the marks. So here, the first one, its frequency, its cumulative frequency is 0. So that is how your graph will look like. Members, are we together? You can put in the chat that we are there. What if the curve fails to be drawn? Jonathan, please always try your best. What if my first, what if my first plot is on the y-axis? That one can never happen. It can never happen that it is. Now that one is an indicator that you have started 10.5 from the origin here, from where your curve meets. When you start from 10.5 from here, that's when it can meet there. That's when it can meet. And that one, always avoid it. You create a class below. Those who want to start from 0, I want to discourage it. That one, I would like to discourage it. Isaac, you can share in the chat. I will be able to look at it. Okay. Now, after doing so, now we have finished that part. We are going to estimate. The supervisor wishes to know the number of people who prefer a weight greater than 25. Please come on your graph. Come on your graph. A weight greater than 25. Check, ask, our weight is 25 grams. Do not cram 25 grams. Ask yourself, where is the grams? Grams is along the x-axis. I want to plot 25. Now, first look out for the scale. Our scale starts from 0.5 to 10.5. So what is we said, get the bigger value, which is 10.5 minus 0.5, divide by how many small boxes are in between, that they are 10. So this is 10 out of 10, which is equal to 1, meaning that each small box contains 1. So in order for you to plot 25 grams or to locate where 25 grams is, I'm going to come on my graph. I'm going to come on my graph. Let me expand it a bit. I'm going to come on my graph here down. I ask myself, 25 grams, where does it lie? 25 really lies between here, in between this. So the lower class in between here is 20.5. So I will say 25 minus 20.5 divided by what each small box contains, which is 1. So I will say now 25 minus 20.5. And my answer is going to be 4.5 out of 1, which is 4.5. Meaning that I'm going to count 4.5 boxes. So I'll come from 20. I say 1, 2, 3, 4. Now, in case it is 4.5, what you do, put it in the next box, but in the middle way. So this is 4, 4.5 is here. After getting it, I'm going to use my ruler to draw up to when I meet my curve. So I'll come, I use a ruler. Please use a ruler. Draw a good straight line up to the point where it meets your line. Draw with the ruler. Afterwards, come and read off. Like that. So that is what I'm getting. Now, this value you have obtained at this point is what you are going to read off. Now, we go back. We say that for this axis, each of our box was containing 0.5. So from 20, we add on how many boxes do we have? 1, 2, 3. This is what I'm getting according to my graph. For you, right, because mine is not accurate, yours is accurate. So I say 3 times 0.5. 0.5 represents each box. Then 3 represents how many boxes have you been able to meet after your graph. So there are 3. So then after I will say 20 plus 3 times 3 times 0.5. And you ask yourself, what do you get? So you end up with, now according to me, here I'm getting 21.5. So that is what I'm getting, but I'm going to ask myself, can I get really 21.5? Then because these are people, then here I will approximate this is 22. But the question was very clear. They wanted people who got above 25 grams, greater than 25 grams. 25 grams, it means that those people had 26, 27, 28, 50, and the rest of that. And now the people we have got here, this region here, is for the people who got below 25. So to get how many got above 25, then I'm going to get my total number, which was 50 people, minus this answer I have obtained, which is maybe 20, 22. Now, after getting this, I say 50 minus 22, I get my answer. But the accurate one, here, the accurate one, let me see. People, what are you getting? Tell me what you are getting, the corresponding one for 25. What are you getting? Uh, 14 instead of... Okay, no, Alvan, I want you to, for you, I'm just demonstrating here, but I know the accurate one is not 22. Yeah, in fact, now let me to give you the accurate one, those who are doing the accurate one. Here, now let me give you the accurate one, but I want to first check out what are you getting for, yes, tell me what you are getting. 28, 28, good, yes, it is 28. The accurate one. So here, just because mine is a freehand thing, it's not accurate, but the accurate one, that one that is very accurate, you must be able to get approximately 28 people. And now, to get those who are above, you'll say 50 minus 28, and you'll get your answer as 22 people. Yes, in fact, now let me show you my accurate one. My accurate one is here. I did that number. My accurate one is here. This is my graph. So your graph should look like this second one. And when you look at it, the accurate drawing, you'll notice that my answer here on this accurate diagram at this point here, I want you to check mine very well and compare it with yours. Here, you are noticing that I got my answer as 28. So this is the accurate one, not a freehand, and your graph should look like that. Hope that is okay. So in case of any question, you can ask based on that accurate one. Okay. Linda and Simon. Yes.
Good morning, sir.
Yes.
Teacher, my question is that, teacher, when we are drawing graphs, do we use pencils or pens?
In case you are very accurate, there is no penalty. You can use your pen. In case you are accurate, but many of those things use a pen. Yeah?
So, teacher, is it better to use a pencil because a pencil can easily rub, but a pen you cannot rub?
But I have seen also pens that you can rub nowadays. If you can get that pen, it is so much the better. The reason is why we can recommend a pen that at times they mark at night, and at times when your pencil is not so sharp, is faint, at times it is very hard to mark your work.
Thank you, teacher.
But for the curve, you can use your pencil, but the rest of the things use a pen, apart from the curve, in case you are not so accurate. Okay. Alvan, let me hope now it is clear. Alvan, is it okay? Okay, hope that one is okay. So here, the number of people you are getting should be 22 people, the accurate answer. But for the freehand, that's how, for freehand, you can, for the freehand, that's how we are getting that. Okay, now I can go back. So here, that's how you are supposed to get. But for accurate one, I've shown you my accurate graph. That's how it should look like, even yours. Here I was just demonstrating. Okay. No, now people here I'm using for demonstration. Chiti, Okay, sorry, I've seen someone. Here I'm using for demonstration purposes, for demonstration purposes. But if you do it accurate on your graph, remember I'm using a free hand. I can never be accurate. I can't be accurate, like you. I can't be accurate. But I've showed you my graph when it is. Now let us summarize this number. Let us first finish and then I can give more things on it. Now, help him or her to estimate this number of people. Now here your conclusion is going to be that the estimated number of people whose weight is greater than 25 grams are 22 people. So that's how you should conclude. That the estimated number of people whose weight is greater than 25 grams should be or is 20 or are 22 people. So that should be your conclusion. And you'll be able to get all the scores. Now, for this particular number, let me use my accurate graph to make sure that I put everything I want onto very well. Now, for this particular number, they can ask you to, there's something, they can ask you, in case maybe someone was asking about quartile, maybe in case it was a percentage. In case it was a percentage, when they say, estimate the number of who would have scored, whose percentage is above 80. Now, for such a case, when they say above 80, now 80%, what you do, you will come and say 80 out of 100 times just summation of F. So here it will be 80 out of 100 times 50. So you come. Then by 5-1 by 5-2 by 2-1 by 240. So you say you have gotten 40. And this is the position. It's not the actual answer. It's not the 80%. Now, after getting the 40 position, here you have got the people. This is the position, the 40. And now you want the weight, because they can say the weight, because summation of F, what you have multiplied with represents people. So the answer you have obtained here is for people. Now for here, what you do, you look out for 40, the 40th position. It is here. Then come, draw. After drawing, come down. And then read off. Here the question can be, estimate the weight. Was the weight if 80% of the people did this and this. So that's how. So you need to know which axis are you reading from. The moment you multiply times the number of people, you are getting the position for the number of people. So you estimate the weight. So you need to be very careful when you are reading. Do not cram. Here, they may be asking you to estimate the weight. Yes, to estimate the weight, meaning that you locate basing on this axis of the number of people, and you come, you check out what weight would it be. Okay. Hope, am I clear on that? Kindly let me know in the chat. Okay. Okay. Now, I'm repeating the last time. I'm saying that when you find percentages, say 50%, take an example here. They had asked us to obtain the median for this particular one. So median, we shall always say median is the half quartile, or what we call the 50%. So I will say 50 out of 100 times my total frequency, which is 50. So what will happen here? This and this will reduce, this and this will reduce. So I'll find myself having my median as the 25th position. I'll come here, check out where 25 is. 25 is here. In case I'm estimating the median, I'll come, draw an arrow here. After reaching this point, I'll come down here like this, and I come and I draw that. And then I read off that point. So that will be my answer. So that's how you have to do it. Okay, let me hope that is very clear. That's how you estimate. The moment you see those percentages, always multiply times your summation of F. Okay, even if it is percentile, even if it is quartile, in case it is now in case it is quartile, for quartile you say 1 out of 4 times the summation of F. In case they say lower quartile, you say a quarter times summation of F. In case they say decile, they can say the fifth decile. Fifth decile means 5 out of 10 times the summation of F. Always we multiply times summation of F. Hope that is very, very okay. Now we are going to go to an okay. Okay. Now that is it about that number. Hope I've done so. Allow me now to open one more number. That was item 1. We have completed it. Let me check out on item number 2. So remember, these numbers we must maximize. Now item number 2. I think, let me read through. I think this one I will send it. Item number 2. Let me check another item. Okay. I think let me use this item number 3. Let's use this. Okay. Item number 3. Now, when you look at our item number 3, I want you to first read through it very well. Read through it, and then I want you to put in the chat, what do you think we need to calculate? Which new idea or concept are you not seeing? So type in the chat, first read through, and then you tell me. Okay, let me start looking through the chat. Assumed mean, Najinda Mason. Najinda, can you tell us why you are saying so? I don't know that Najinda, you can speak to us.
Yeah, okay. So in the question, it says that I'm going to start from, it is assumed that every farmer will receive 270 kilograms on average after sharing equally. The average represents the mean, and the part where it says it is assumed, that means assumed mean is 270 kilograms.
Okay, very good, very good. Yes. So please, this was one of the mock papers. So please, this was very crucial. It is assumed that every farmer will receive 270 kilo on average after sharing equally. Now here, it is where we bring in the concept of assumed mean. Now, the first thing now we have to do is, after doing so, they're asking you that use your expertise and organize the above information so that it is well understood and suggest whether the assumption was right. Remember, the ministry wants to give now you need to read through, because also this one has some concept. The Ministry of Agriculture and wants to identify not more than 10 farmers whom they can support with some inputs, whose weight did not exceed. Now, it means that here you must estimate whenever they give you figures. It means that you must estimate something. And what we are going to estimate for this particular one, it shows you that we need to draw a given graph. Now, in the chart, which graph do you think we are going to draw for this particular number? Because we have to estimate how many people had a weight that was not exceeding 210.5. Which graph do you think we shall need if they ask us to draw it? Very good, Ruth. Yes, Lucy. Yes, it means that now we shall use an ogive. Whenever they tell you to estimate, they have given you a figure, they have given you a number, they have given you a percentage, then please an ogive should come into your mind. Okay, now we are going to organize. I want you to look through, identify your lowest value and the highest value. The lowest and the highest value. And then decide which class interval are we going to use. Identify your lowest value, identify the highest value, and then decide which class interval are you going to use. Check through all your data you have. Identify what is your lowest value, what is the highest value. Then I want you to decide what are you going to use. I'm waiting in the chat as people. Looking through the chart, lowest is 150, highest is 400. Good. So I'm saying that the lowest is 150, highest is 400. Good. Now, we said, now remember, I told you, when our digits are between 1 to 100, I told you our class interval, the good ones are 5 and 10. When our class interval when the digits increase 100 to maybe 1,000, here our class intervals are going to change now, not 5 and 10. Now there will be 5 times 50, 100. When it increases to be 500, 1,000. Hope that is clear, members. Check out when the numbers go as they go bigger, bigger, bigger. That's what you do. Okay. Ruth is saying the class interval is 50. That's what she wants to use. So let us check. So I say highest is 400 minus 150 divided by the class interval, which Ruth has decided to use as 50. I told you when you are placing in the calc, please put those brackets to avoid making errors. So, according to what I'm seeing here, when you use this, Ruth, how many classes do you have? Those who are using 50, how many classes do you have? Kalemanol, I'm repeating. To know how many classes, the first thing always we want, how many classes are you going to be able to generate? So to find how many classes you're going to generate, always get the highest minus the lowest, divide by the class interval you wish to use. So here, I'm going to, when you do this, you are going to see that you are going to get 5. You get the answer as 5. Now I want to let you know, any moment you get an exact number, always know that there is an additional class that is going to come. So here, there are going to be 6 classes. When you get an exact number, you'll find that there are going to be 6 classes, which is very good. Those who are trying 100 as their class interval, you are not saying that for you say, I'm going to use 100 as my class interval, you are not going to notice that for that one, you'll form only 3 classes. Your answer is going to be 2.5, which is 3 classes. That one is very bad, very poor. You throw it in the dustbin. You cannot use it. So here, our class interval is going to be 50. That is going to be our class interval. But like I've said, after getting your class interval, always remove 1. Remove just 1, and then you continue. So I'm going to come here, and I draw my table. Now in my table here, today let me draw a big table to have many of the things drawn. Now when you look at the table, I want you always, don't put here the word class. I want you to be specific. What are they talking about? They are talking about weights in kilograms. So I'm going to come here and I say weight, and this is in kilograms. And then I draw this. After my first class, our lowest was 150. So let me see whether members can generate for me the first class. What is going to be our first class? You can type in the chat. I want to see what is going to be our first class. Our class interval is 50. So type in the chat. You're going to have 152. Very good, 6. Yes. Hope everyone is seeing. Yes, the answers coming in are very good. Thank you, Happy. So it will be 150 to 199. That is the first thing you have to do. So the rest, we said here lower, add 50, add 50, add 50, the rest. So this will be 200 to 249. This will be 250 to 299. This is going to be 300 to 349. This is going to be 350 to 399. This is now when you look at when you consider only 5 classes, you will notice that some figures are left out. So that's why I'm saying when you get an exact number, always add one more, that there will be 6. So this is going to be 400 to 449. I don't know whether all the classes, our highest was what? I think now all the classes are being covered. The next one is going to be the tally. I want you now, can you do for me the tallying? The next one is going to be frequency. I want everyone to first complete his tally, and then we compare the results. So let me leave you, do the tally. Let me give you about 4 minutes. Let everyone do the tallying now. Oh, I don't know whether people had copied the table. Okay. Do the tallying, do the tallying. Okay, let me minimize. I know some people were still on the table. Oh, I think the question is very lengthy. Yeah, so do the tallying. We are doing the tallying. Okay, let me hope we are somewhere with the tallying. Okay, I'm going to finish. I'm going to do mine. I'm also doing mine here. I want us to compare notes. We are going to compare the notes. Okay. Okay. Kindly let me know in the chat whether you are finished. In case you are finished, you just say yes, yes, yes. And then we check out whether we can continue. are still tallying. Make sure you cross out. Okay, someone has finished, one person. When we get, okay, someone wants us to zoom. Okay. Okay, I think we can continue. Allow me to display mine. Yes, and you just confirm. In case mines are not right, you let me know. But I've said for you, don't need to draw these lines, but just because for me, I don't have them. That's why I'm drawing those lines. But for you, you don't need to draw them. According to my tally, here I have 1, 2, 3, 4, 5. Here I have 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5. 3. Yes, 1, 2, 3, 4, 5. I have 1, 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. And then a 1. Kindly, I want you to let me know whether you have similar work or whether my work is totally different from yours. In case we have the same work, it is okay. In case my work needs to be repeated, you let me know. Are we having the same answers? Okay, Ruth is saying, yeah, yes, same. Okay, good. Now, we go back to the question and first find out what we need to know. Now here, the question, they told us that use your expertise and organize the above information so that it is well understood and suggest whether the assumption was right. Remember, our assumption required us to find out whether the average that everyone will get 270. This is what is assumed. Now, when we are looking at assumed mean, there are things you need to remember that assumed mean or assumed mean, assumed mean or the formula for mean, or let me say the mean, you'll always need A, which is the assumed mean, plus summation of f of d out of summation of f, where d is the deviation, which is equal to x minus a. So meaning in our table, we are going to include, one of the things we are going to include, our mid value. So I say mid value, which I'm going to write as x. Then after the mid value, I need the deviation, which we are going to write d is equal to x minus a. Now, like we have said, you define it. So you are going to come here down and say a is equal to assumed mean, and in brackets you can say which is 270. Which other thing, anything that you have not defined in the table. So now we say to get the mid value, we are going to add the weight. We shall say 150 plus 199, everything divided by 2. Can we have someone raise up the hand and you tell us what you are getting? Or you can take us through. Anyone? Okay, Ruth, you can take us through. Okay. Imran, you are going to come to the, okay. Yes, Ruth?
Okay, so 150 plus 199 divided by 2 gives us 174.5. Then 200 plus 249 divided by 2, 224.5. 250 plus 299 divided by 2, 274.5. Then have 324.5, 474, sorry, 374.5, then 424.5. Yes.
Okay, good. Imran, I saw your hand up. Imran, can you give us the deviation now?
For the deviation, the first one we shall get 174.5 minus 270. Sorry. 174.5 minus 270, which is a negative 95.5. The next one, 224.5 minus 270, which is a negative 45.5. Next one, 324.5 minus 270, it is 54.5. The next one of 324.5 minus 270, sorry, 374.5 minus 270 is 104.5, and 424.5 minus 270 gives us 154.5.
Okay, very good. Now, when you look at our formula, you notice that we shall need FD. So FD, this is the frequency. Don't forget we have to define. So here in brackets, put F. So we shall have FD. Yes, can we have another person to give us what you are getting for your FD? FD means multiply F times D. Any other person? You can raise up the hand. F and D. Okay. Yes, Najinda.
Okay, so for 5 times negative 95.5, it is negative 477.5. Then for 7 times negative 45.5 is negative 318.5. Then for 11 times 4.5 is 49.5. Then for 7 times 54.5 is 381.5. Then for 5 times 104.5 is, sorry, give me a second. 104.5 is 522.5. Then for 1 times 154.5 is 154.5.
Okay, good. Can you go on and you get for us here the summation of F of D? Others you can also add and you drop for us. Yes. Okay, Elite, that is very good. After getting the interval, you can keep on adding the class interval. However, do not take it as gospel truth. Also, it doesn't apply when the class intervals are not the same. But like I said, at this level, class interval will be the same. Yes, Zex, that assumed mean you read the question. Yes, Najinda?
I get 312.
312. Okay, good. Now, we can first complete that our table very well. Now, our table, we have noticed that our part B required us to have an a statistical illustration. But since we are going to be estimating, we say that that one will require us to have now a cumulative frequency curve. So in your cumulative frequency curve, what do we need? We shall need the class boundary, but let me start with cumulative frequency. I put cumulative frequency, someone to give us the cumulative frequency, and then we shall need a class boundary. Who's willing to give us the cumulative frequency? Okay, Star Boy. Star Boy, unmute.
All right. We have 5.
Okay.
Then plus 7 is 12. Plus 11 is 23. Plus 7, 30. Plus 5, 35. Plus 1, 36.
Yes, very good. Then the last one is the class boundary. So for the class boundary, still we do the same. Subtract the 0.5, add the 0.5. So this one, allow me to just write. It will be 149.5 to 199.5. This one will be 199.5 to 249.5. 249.5 to 299.5. 299.5 to 349.5. 349.5 to 399.5. 399.5 to 449.5. So, but make sure for you write it because mine cannot fit. That's why I'm trying to squeeze. Then after, make sure your table is very close there. And never break your table into 2 parts. Never. Always try to squeeze your things very well or plan better. Or plan better. Then do not forget, we said we must always have a title for our table. So we shall say a frequency distribution table showing what is it showing or what is it about. This frequency distribution table is about farmers of Mwenzo and there is I've got the following weights of produce. A frequency distribution table showing the farmers, the weight of the farmers produce or the farmers produce of Zowezo village. That's how you state your title. Now we are going to go into the calculations. Now the calculations, oh, I did not create a page for this. Now, for our calculations, now I'm going to use this space here to obtain the calculations. Now, the first one, we are going to calculate part A that required us to prove whether the assumption is okay. So we know that our mean will be given by A plus summation of f of D out of summation of f. So our assumed mean, we said it 270, so I would say 270 plus summation of FD, which is 312 out of 36. So this one will give us 270 plus. Here, when you divide, you'll get 8.6667. And this one will give us 278.67 kilograms. So then, since then you are going to write it to an approximation, which is 279 kilograms. Now you ask yourself, because you are comparing it to a whole number, but have both answers. First write the first one, and then you can write approximately to 79. That is my weight. Then what are you going to do? You go back to the question they asked you. Use your expertise and organize the above so that it is well and suggest whether the assumption was right. The assumption was that at the end, when they share, they will get 270 kilograms. Can someone tell us this is our exact value we have obtained after calculation? Their assumption was 270. Was the assumption right or wrong? Or how can we conclude now? How do we conclude? Someone to tell us how you'd conclude for such a case? Anyone to conclude for us? Okay. Now, when you look at their assumption was 270. So your conclusion would be that the assumption that each farmer would receive 270 kilograms on average after sharing equally is not correct, because the exact value is higher than the assumed value, i.e. 279 kilograms is high compared to the 270 kilograms that they had assumed. Now that is a conclusive statement. Yes, Isaac. Yes? Oh, Isaac, you're not clear? Okay. Okay. Now that is for part A. So that's how you conclude. I repeat, I said the assumption that each farmer would receive 270 kilograms on average after sharing equally is not correct, because they are calculated value, or basing on my calculations or basing on calculations, it is noticed that the mean is 279 kilograms, which is higher than the assumed one of 270 kilograms. Okay, so that is how you can make your conclusion. Yes, your guys, that is okay. Yes, yes. Now, okay, why I rounded, I've said put both answers because weight, yes, it can be to kilograms, but you know very well, when it comes to dividing things, at times it is very tricky for you to measure the 0.67 in real life. Measuring 0.67 at times is a bit hard, so that's why I have approximated, but it is okay for things that can be measured, like weight. At times we don't penalize when it comes to decimal places. But since the number I'm going to compare with in my conclusion is a whole number, that's why I'm using, so that's why I'm using that decimal. That's why I'm using a whole number, because I'm going to compare it. Now, Trevor Banis, standard deviation is not at your level. A standard deviation is not at your level. That is a level work. That is a level work. Yes, you'll meet it next year. I don't know how you got here. The only thing you need to look out in this the only thing you need to look out for is just deviation, and deviation is this simple deviation, but the standard one, that one is for a level. Okay. On the class boundary, what if the class is in decimal places? How do I get the answer for it? Now when it is okay, for that one, when it comes to class boundary, okay, I will answer those questions at the end. Let's first complete this question. So that is for part A. For part B, with the help of a statistical illustration, determine whether the support was to be given or not, and if it was given, how many got. Now here, the first thing we do, we are going to draw our cumulative frequency curve. And then you come back here. They told that the Ministry of Agriculture and Animals would identify not more than 10 farmers whom they can support with some inputs from those whose weight didn't exceed 210.5. You are going to allow me that I summarize and I use my graph that I've already drawn. For you, you'll draw your graph. You draw your graph, but allow me to use the graph that I have already here, that I've already drawn, such that we don't take a lot of time on it. Hope that one you have allowed me. Yes, you are going to, since we have already tried out cumulative frequency curve, yes, allow me that that I just use this particular graph that I have here on my screen. So what you are seeing on my screen is the graph. Is the graph that you are supposed to get when you draw. Now, what happens is that now we have to estimate according, which is 210.5. So what you are going to do after coming up with your graph, we are estimating 200.5 kilograms. Still, come on your graph, check out where it lies. Now, that particular one that we want 210.5 kilograms lies between 199.5 and 249. So you will say 210.5 minus 199.5 divided by, remember our class interval was 50 divided by the 10 boxes. So here you get 5. So I will divide by 5. After dividing by 5, the answer I get, I will count how many boxes I'm able to form. So I'll say 210.5 minus 199.5 divided by 5, and it is approximately 2.2 boxes. So when you look at my graph, I counted 2.2 boxes, and then after I come where it meets my graph, I read off this value. So when you read off this value, according to my graph, I notice that the value I'm getting there is 7. So you'll check out whether you also come up with 7. Now, after getting the 7, here my assumption is that we shall be able to do it in our free time, or we shall be able to complete. Now, here you come and say that the ministry said that not more than 10 farmers, but according to your estimation, not more than, it means that there must be less than 10. So according to your graph, you are noticing that you have obtained 7 farmers from your graph. What does it mean? Because they said they did not exceed, that's why we are taking the value the way it is. If this was it exceeded, then we shall have subtracted. But since they have told they did not exceed, it means we read it the way it is. So here our answer is 7 farmers. How are you going to conclude? Because you must conclude with a statement. So we can say that since the farmers whose weight didn't exceed 210.5 kilograms are 7. Therefore, the ministry will be able to offer the support since 7 is less than 10. That's how you'd have concluded for part B. Then for part C, they say that what is the chance that a member from the association is going to visit the fertilizer factory in Tololo? They told that the fertilizer factory is to facilitate farmers who got above 310 kilograms of produce. So you'll come back to your graph. This is our graph. You check out where is 310. So 310, we say that in order for you to obtain it, still you do the same say. You say 310 minus 310 lies in between these two. So minus 299.5 divided by the 5. 5 has been obtained because that's what each box contains. Now the answer you obtain, draw. Now this is where we have our value. But they told us in the question, farmers who had above 310. So when I read off from here, I'm getting my answer as 26 from here, from my graph here. Now, being that the answer is 26, we want those who got above. So meaning that those who got above is this region above here, here. So what will I do? I'll get my answer, my total number, which is 36 minus 26, and I get 10. So that means that farmers who got above a weight of 310 were 10 farmers. But since they have asked for the chance, so chance is probability. So meaning that I'll come and I say that the probability of the farmers who got above 310 will equal to 10 farmers divided by the total, which is 36. So here the answer I'm going to get is 0.277. But since now I want to give I want to give a figure, I can write it as a percentage, and I say 27.8%. So I conclude and I say there is 27.8% chances. Why am I using percentages? Because whenever you are communicating to someone, a percentage, a decimal, and a fraction, one of those ones is easy to communicate and understand. The easiest one to understand is the percentage. That's why I'm using a percentage. When you tell a layman 0.277 chances, he may not be able to understand. So I will say, therefore, there is 27.8% chances that someone that is randomly selected will be able to visit the fertilizer factory. Then, the percentage is for the conclusion. You are communicating blessing. You are communicating the conclusion because they ask you, what are the chances? When you look at the question, remember, when you are writing when you are giving probability, probability can be expressed as either decimal, a fraction, or percentage. But they're asking you, what is the chance that a member from the association is going to visit the fertilizer factory? And the condition was that person must have obtained above 320 kilograms of the produce. And when you read from the graph, we notice that it is 10. There are 10 members out of the 36 members. So that is why I'm saying that in my conclusion, instead of me giving a decimal or giving a fraction here, because in decimals it will be 2.77, and in case I'm writing it in a percentage, I multiply by 100, I get 27.77, which is approximately 27.8%. So when I'm communicating, percentages are easy for me to communicate in compared to when I am using decimals and fractions. That's why I have decided to use a percentage. Okay, I think, okay, why did you subtract? Because when you look at our graph, we want to find out where is the 310 lying. When you look at my graph I've drawn, you are noticing that 310 is lying between 299 and 349. So in order for you to plot it, you get that value you want to plot minus the value from within the range you want to plot, which is 299.5, divide by what each box contains. And we said our class interval, since it was 50, and in between the two classes, we have jumped 10 boxes. It means that each box contains 5. So I get this value I want to plot minus the one that is lower in its class interval, divide by 5. So that's one. Okay. How did you get the vertical scale? The vertical scale, like we said, vertical scale, I will always check in my table. Look in your table. When you look at your table here for this is our table. When you look at our table, you can easily notice that our highest value, you can notice that our highest value here under the cumulative frequency is 36. So I will say 36 minus the smallest value, which is 5, I divide by 10. So when you say 36 minus 5 divide by 10, you get your answer as 3.1. So under the convenience scales, we know we have 1, we have the 2, and the 5. So 3.1 lies between 2 and 5. So that's why we used 5. Okay, I'm just now responding to a few questions in the chat. How did you get D is equal to X minus K? Now, deviation means, let me use your class marks. In performance, always we set targets for ourselves. You can say that this term, I want to score on average, or I want to score maybe a 30. Let me say an 80 in math, 80%. Now, in case you do a paper and it comes back and maybe you have obtained 90, you ask yourself, how far did I go from my predicted value? How far you went is what we call the deviation. You can either be below or above, or you can get exactly. So deviation means how far did someone go away from the assumption he or she had made. So that's why now here your deviation will be what you had assumed, which is what you had assumed minus what you obtained. So here we shall say 90 minus 80, which is 10. A positive value means that you have added on to what you had predicted. A negative value, it means you have obtained below what you had predicted. So when you score below 80, you will get a 70. So you will be negative. That's what we call a negative deviation. You have gone below your expectation, meaning you must work extremely hard to hit your target. When you get a positive, it means that you need to keep or to maintain. When you obtain a 0, it means that you need now to put in more efforts because there's no improvement at all. Okay, let me. Elite, it is okay. When you are plotting, use the approach you are very conversant with. If we are applying the way plotting, like plotting value minus divide by number. Yes. Now, Elite, you are going to remember that one only works if you have started from 0 or from your starting value. That one is also okay. Plotting value minus the starting value divided by the number of small boxes. It is okay. You get the same answer. You get the same answer. Though here you have to count very many boxes, but it is very okay. Okay. Let me hope I've answered all the questions according to what I have seen in the chat. Where did I get the 5? I've said the 5 is because our class interval, when you are looking for the scale to use, always that scale, you can use your class interval for class boundary. So when you look at here, to obtain when you look here, you can notice that we are starting from 149.5 to 199.5. So the difference between the two numbers is 19.5 minus 149.5, which gives us a 50. Meaning that between 149.5 and 199.5, you have an interval of 50. Now this interval 50, you ask yourself that from 149.5 to 199.5. How many boxes do I have? 1, 2, 3, 4, 5. 1, 2, 3, 4. That I have 10 boxes in between. But what does each box here contain? So that's why we divide by 10 boxes and we get 5. That means that from each box here has, this is 5, this is 10, 15, 20, 25, like that. That's where we are obtaining. So you are looking for what does each small box contain? Okay, I think let me attempt the very last question. When does deviation come in? Now, always reading the question and understanding is very key. Now, for this particular one, we brought in the deviation because they assumed something. They assumed something and they wanted us to prove whether their assumption was okay. Whenever you find that there is an assumption, assume that every farmer will receive this on average. We said average is what gives us a hint about mean. So since they assumed something, it means that is where the concept of assumed mean comes from. And the concept and assumed mean, we know it very well from senior free statistics data and collection. We say that whenever they assume something or they give you an assumed mean, always this is the formula you use. And we say that D stands for the deviation. How far someone deviates, how far someone goes away from his assumption or from his prediction. What if I just count from the table if they have not specified for diagram? Can I be marked? Right, I want to say you lose a lot of marks. Reason being is that when you count from, I want to discourage it wholeheartedly, because when you start those things over counting, at times there are some numbers you are going to fall to not to include, though you can get the exact answer. But in case the question has 5 scores and for you just count, you'll get 1 mark for your final answer you have put. You have not shown how you have got. In mathematics, we want always to show. But always let the marks on the question guide you. In case you see 10 and for you think when you count you'll get your 10 marks, it is very well. But I always advise use the counting approach as use that counting approach as a way of proving your answer, as a proving approach. But do not based on it, because at times they can award or put a lot of scores. And do not forget that this number has 20 scores. So they are going to look for all the avenues where they can put the mark. They look for all the avenues where they can put the what? The mark. Because at times it can be very hard to reward the marks. Okay, I think we have exhausted. Okay. Okay, the lesson I'll upload it on the YouTube. You are going to give me a okay. Okay, now the number I want you to try, let me give you one number. You are going to try in your free time. You will try for me this number in your free time. I think we have not done it. Time couldn't allow. But write it, take a screenshot. You'll try it in your free time. Try it, and you have noticed that there is percentage. What should come to your mind now? There is an ogive somewhere. I want you to learn how to use the ogive very well, much as you can also use the calculation. Much as you can also use the calculation approach. Okay. Okay. I think let's stop here. Let's stop here for today. Let's meet tomorrow. And tomorrow when we meet, I think tomorrow let me go to another element of construct and I look at linear programming tomorrow. God willing. Yes, Kalema.
Hello, sir. Morning.
Good morning.
I was asking for your help on how to get the class boundary.
Okay. Any class boundary? Oh.
Any. Yes, the
Okay.
formula.
Okay. Now, when it comes to class boundary, let me say the class is, okay. Okay. Let me say your class is 150 to 199. Or 200 to 249. What you do to get the class boundary, you can say 0.5 times 10 power negative n. N stands for the number of decimal places. Now, so that 0.5 or what we add, it is the error in the number. Now, when it is 150 and 199, this is a whole number. So n is the number of decimal places. So it means that n is going to be 0. So you say 0.5 times 10 power negative 0. Anything power 0 is 1. So I have 0.5 times 1, which is 0.5. So here you add and subtract 0.5. So to obtain the class boundary, on your lower class, subtract 0.5. So you say 150 minus 0.5. On the upper, you add 0.5. You say 199 plus 0.5. In case it was 150, let me say your class was 1.0 to 2.4, and this is your class. Now here, you notice that the decimal place is 1. So you will say 0.5 times 10 power negative 1. So here your answer will be 0.05. So here you add 0.05 and subtract 0.05. Lower add, lower subtract, upper add. I don't know that, Kalema, I have answered your question. Kalema, let me know.
Yeah, thank you, sir.
Okay. Dr. Hilary.
Yeah, you're.
Okay.
Excuse me, sir.
Yes.
I've heard you talking about the ogive sum, and for us it's like we have come late, so really give us belief about that.
The what? Yes, ogive curve is a graph where we plot cumulative frequency against the class boundary. And always use your free hand. When you plot upper class boundary against cumulative frequency, you'll get something that is like a curve. So you use your free hand in order for you to come up with. I don't know that Hilary have helped a bit. Hilary, is that fine?
Yeah, that's fine. I've
Okay,
got the
but you are going to
concept.
find more details, eh? You are going to find more details, eh? In the video.
Yes, excuse me, sir.
Yes.
Excuse me, sir.
Yes.
Why don't you drop us the elements of construct in a, we have made a group as senior fours, so we shall you to just drop us the elements of construct and other scenarios so that we can try out. How do you see it?
Excuse me, sir.
Okay, it will work, but you are going to give me some time, eh? I have them, but I think I may need some few minutes. Okay, let me say, you remind me late in the evening to gather my resources. Yes, Blessing, but I will do so
I
here.
have only one question. Where do we submit, like, after doing the work?
You can send in my inbox.
Oh, okay, sir.
But you send me some constant reminder in case I take long to reply.
Okay, please.
Okay. Trevor, Imran.
No, like I think it was the same question with her, like submission of the work.
Oh, okay. You will send. Kalima, any other thing, and Imran?
Master, for me, I was requesting on your timetable because for us, we only do the morning lesson. So we're asking which other
Excuse me,
lessons
sir.
you.
Okay. But what I know, after here at 10, there is ICT, there is chemistry at 2. Lessons always at happening at 2 p.m. Then math always happens from 5 a.m. daily for 2 consecutive weeks now. It's going to be for 2 consecutive weeks. And we shall always cover something. Yes.
I'm requesting that they can send that item that you have left us to try out in the group, because we cannot actually screenshot it because I'm using a phone.
Yes. Okay, I'm going to send it. You are going to give me some time and then I will send it there.
Okay, thank you.
Okay. I think we are going to end here. Let me wish you a good day.
Hello?
Yes.
I was telling my brother that I will send it to them. I screenshot it. I'll send them. I'll send the question to them.
Oh, okay. Perfect.
I'm in the group. Yeah.
Okay. Okay, perfect. Yes, I will send you those elements of constructs for all those subjects. But those who can check those WhatsApp, the YouTube channel, we had those seminars and the introduction, all those elements of constructs we are talked about, but I will send them. Yeah, but I will need some reminders.
Okay, thank you, sir.
Okay, let me wish you a good day. Bye. Let's meet at 10 for those who are doing ICT, and those for chemistry, let's meet at 2. Have a good day, and thank you so much for attending. Take some break, and then you go on and read. Bye, everyone.